Ladies and gentlemen, please welcome Chief Technology Officer of Amazon.com, Dr. Werner Vogels.
Wow. Good morning, Vegas. Come on, can I get some love? Hey, good. How are you all doing? Yeah, pub crawl last night? You survived, at least. Thank you all for taking the time and showing up here this early. This is my favorite time of the year, absolutely. So one thing, yesterday probably you were been absolutely amazed with all the things that Andy announced. Yeah, and so many different things, so many advances in AWS that I actually thought I would do something different. So if you're here in this room today for announcements, you can leave now. Yeah? Maybe there's one or two, but I won't tell you where it is. Yeah. For me, this is sort of a little bit of an anniversary. Yeah, it's 5 years ago, we started off in 2012 with reInvent. That was a small, intimate event compared to this one. Although I like this one. Yeah, look how happy I was. Yeah, it was amazing, and I really loved that presentation. Looking back 5, 6 years now to that time, I got an opportunity to really talk about sort of how our customers were radically reinventing the way that they were developing their applications, and could give them lots of advice about sort of the experience that some of them had, and it may be relevant for other customers as well. And there were no announcements in that keynote, none at all. And so, in my mind, going back, that is actually still the most favorite presentation I ever gave at reInvent. And I thought for this year, I would just go back to that. Because we've been doing so many things, and it has had so much impact on the way that we're developing our systems. Maybe it's time to sort of revisit that presentation, or sort of the 21st century architectures, because a lot has happened in the past 5 years. Radical things have changed in development. And so maybe it's just time to sort of revisit some of those lessons learned from many of our customers. And I hope that for you in the room, and for maybe others watching on the live stream, and I know that there is even viewing parties out there, that this might be relevant for you as well. So going back to 2012, I sort of divided things up into 4 different categories in those days. I told that sort of these architectures, if you really want to build them in a scalable manner, they need to be controllable. That meant sort of decomposing into small building blocks, that each of those you could control, have different scaling capabilities. We didn't talk about microservices and things like that yet, but that's definitely how we know them now. They need to be resilient. Yeah? You need to protect your customers. You need to be able to, and I think my advice was, deploy to at least 2 availability zones. I think that's sort of standard for everybody these days. Adaptive meant that do not make capacity decisions up front. Yeah? And you're allowed to make mistakes. Build your systems first, and then see which instance types best fit them. In those days, we had not as many instance types as now, so that advice actually still stands. And make data-driven decisions. That meant that don't guess. Start running, start testing these things in production, and then use facts to drive the way that you build your systems. Now, since those days, we've launched a few new services. Yeah? Actually, we launched 3,959 new major features and services since that day. As you can imagine, this has had somewhat impact on the way that we've done development, and that development has changed. And so the title for today's talk will be, again, 21st century architectures, but reimagined. In now all the tools that you have now today, how do we do development? And there's many different areas that we can talk about. I'll pick a few. And I'll pick a few also about how I think sort of the coming 4 or 5 years are going to look like in terms of system development, in terms of what are the real drivers for how we are going to build our systems differently. And of course, I don't have a crystal ball, because 5 years ago, at the first reInvent, I absolutely could not have predicted that I would be here 5 years later. No. It clearly was that we had built technology that meant a lot for our customers, and that allowed them to be successful in ways that they could not be before. But I think there's another part to the crucial DNA of AWS and of Amazon, is that we are not building this by ourselves. We're not in a sort of an isolated environment thinking about this is how you shall develop your software. Because one thing that we knew almost from day one, that if we were going to be successful with AWS, it was going to be radically changing the way that we're building our systems. And with that, we weren't that arrogant to say, and then we shall tell you how to do it. Now, our goal has always been to build a whole collection of very nimble and fast tools that you can decide exactly how to use them. And to build those tools, we needed your help. And I know that these 3,959 major features and services sometimes have been confusing and frustrating, the pace at which we've rolled them out. But much has that to do actually with you. Because each and every one of our service teams has a whole set of customers that they are in very close contact with, and allow them to drive their roadmap. We don't determine, we determine some of our roadmap, but we allow our customers to drive it. So probably one of the cool examples in the beginning was that when we launched DynamoDB, we knew customers wanted secondary indices. We didn't launch with it, though. We launched without it, with a minimal feature set that was rock solid. And then we worked closely with our customers to determine what should be the roadmap after that. And of course, secondary indices showed up there, but there were other features that also showed up that we hadn't thought about at all. For example, IAM-level item control. The fact that you wanted to set access controls on individual columns and rows. We hadn't thought about that, or at least we thought about it, but we didn't know that that was going to be extremely important to your customers. And so we allow you to set our roadmap. And this very quick iteration then means that we are delivering tools that allow you to develop the way that you want to develop. Not the way you were developing 2, 3 years in the past, but how you want to develop now. Yeah, so always think about that we are delivering the tools now for the systems you want to be running in 2020. And definitely, if you look at Andy's keynote yesterday, many of those services will allow you to build those applications and systems that are going to target your customers in the coming 2, 3, 4, 5 years. So we continue to build services for the future, not for the way that we were developing in the past. Now, if we look at sort of our drivers these days, that are sort of creating these radical shifts in the way that we're developing software, there's sort of 4 things that I want to pick out. There's probably many more, but these are sort of, in recent days, definitely that I've been thinking about, well, yeah, that's really shifting the way that we're developing our software. The first is data, and that sounds there's a bit of a general term, but if there's one thing that cloud has done, it has created a complete egalitarian platform. Everybody has access to the same compute capabilities. Everybody has access to the same storage. Everybody has access to the same analytics. And if you don't have the algorithms yourself, you can buy them. So what then becomes the major differentiation between different companies next to, say, the unique sort of business logic that you have, what's going to set companies aside is the quality of the data that they have. And whether it is data about your customers, whether it's data about your manufacturing processes, so that you can actually build data-driven environments and data-driven systems that optimize the way that you build new products, that create safety on your factory floors. Data will have a crucial impact in the way that companies are changing their behavior, or are building new systems. A great example there is, I think, GE, General Electric. So Jeff Immelt, the departing chairman of General Electric, once said that, one night you go to bed as a manufacturing company, the next day you wake up as a software and analytics company. And that's really the transition that GE is going through. GE is investing massively in creating analytics tools, both for their internal processes, as well as delivering Predix, which is their large analytics environment that runs on AWS, to help their customers be more effective with the equipment that they've built from GE. And they are providing these services now also to their competition. They're really shifting from being, at core, a manufacturing company into a data and analytics company. And given that GE is almost the only company left, or is the only company left on the S&P 500, on the original S&P 500, their adaptiveness really shows the transitions you have to go through if you want to be successful in the future. Another shift, I think, driver in the shift, technology driver, is IoT. The capabilities that we've been developing at AWS allows a whole environment to become active. And what I mean by that, I think that every device that now draws a current, it has the ability to become connected and to become an input or an output device of the systems that we're building. Other technology drivers, I think, if you looked at all the machine learning services that we launched yesterday, they have been enabled by core fundamental changes that has happened in the past 2-3 years. The availability of the P3, the P2, and the P3 instances, as well as advances in the infrastructure pieces such as MXNet and TensorFlow, have driven the fact that we can now build neural networks that we can execute in real time. And that's a major shift. It's not just that we can do machine learning in sort of an offline fashion. No, we can execute these in real time. And Amazon, the retailer itself, has been a long user of machine learning, but most of those processes were sort of not necessarily real-time ones. Inventory level setting, price prediction, all these tools, or is it abusive review detection, none of those mechanisms really needed to execute in real time. But now, with these new hardware and new software advances, we're able to execute neural networks in real time, and that sort of drives a complete shift in the way that we're going to access our digital systems. Now, if I look at the interfaces to many of our systems, now, today, or actually historically, they have all been driven by the capabilities of the machinery. Screen, keyboard, mouse, finger, maybe. And the way that you interact is through, indeed, the green character terminal, or through web pages, or for cards on your phone. This is not the way that you naturally interact with each other. It is driven by the capabilities of the machinery. And us digital natives have sort of become used to that. Each of us know exactly how to manipulate your search engine with weird keywords to get exactly the answer that you want. We're not doing some fuzzy natural language query. No, we know exactly how to manipulate the machinery. And it's mostly because the interfaces to our machinery have been created by the capabilities that the machineries had, not how we want to communicate. And so I believe that the interfaces to our digital systems of the future are no longer going to be machine-driven. They're going to be human-centric. Because now, with the advances with the P3s and the MXNets of this world, we can build neural networks that can execute human natural interfaces at speeds that allow us to build natural feeling interfaces to our digital systems. And with that, our whole environment will become active. Anything that you feel as normal human communication, and it might be voice, it might be vision, it might be touch. I'm not really sure we really can do smell, but maybe that's possible in the near future as well. Things that we as humans use to communicate are going to be the normal interfaces to our digital systems. And so I think the first step in that, of course, is going to be voice. Yeah, we have already reached that point with all the advances in automatic speech recognition, natural language understanding, text-to-speech, all of those. Yeah, we already see that sort of we have this shift going on. And this is normal because this is, here, look at us. We're talking. This is not a Slack channel. Yeah? I'm actually talking to you, and apparently you all come here to listen to hear someone talk. This is a normal interface. This is a natural interface, how we interact. And so, in all places, you talk to the people next to you. That's how you interact. You're not, if you're sitting next to you, you're not sending text messages to each other. It's a natural way of interacting. And in our digital systems, we kind of have lost track of that. Because in our digital systems, we use all these cards and pages and things like that. And what voice will do is allow you to have a normal, natural way of communicating. The surgeon in the operating room will use voice to actually manipulate the machinery around her instead of having to take her hands off the patient. If you're a young dad and your kid is ill, you don't want to go onto a website and fill in a form. You want to scream at something. And preferable in a very, let's say, fuzzy manner. Yeah? And where there is an interaction happening there with a question and answer, where the other side actually understands that you're in panic and comes back at one moment with the advice that you're looking for. That's a normal way of interacting. And well, the last thing is actually something that happens to me all the time. You know, I like cooking, but I'm a stupid European and can never remember how many milliliters go in a cup. Yeah? And then you have to clean your hands, and then you have to go to your cell phone and actually type the query in. Yeah? Instead of just using your voice to ask your environment to give you the right answer. And more importantly, I think there's something else happening when we use natural interfaces. I think currently our digital systems are being limited in their application to us digital natives. Because we know how to use keyboards, we know how to use screens, yeah, we know how to use all these apps. But if you've ever given a tablet to one of your grandparents, what you know is that they do one thing, hit that Skype button. And that's about all that they do. However, if it would have a natural interface, voice, they may be actually using their digital systems in many different ways. Yeah, or young kids that actually can't read or write yet. And we see that many different, and we also see that those digital natives, that once they have actually gotten the access to a voice-driven system, they get pretty annoyed if you have to go back to your cell phone. There's also something which I like to believe that is happening, is definitely happening to me, is something called app fatigue. Yeah? Where, no, yet another app to learn. Which app do we need to use for this one? And where once you've actually been talking to your digital systems, you no longer want to go back and actually have to type things in or look for apps or things like that. There is another area where I think voice will be crucial in unlocking our digital systems for everyone to use. Yeah, if we look at developing countries around the world, forever we've been saying smartphones will unlock the internet for those people to use. Well, it's definitely not happening, is it? And why not? Because, believe me, apps is not the first thing on those people's minds. Surviving is probably first on their mind. Yeah? And so if you look at most of it, they don't have cell phones. Maybe they have an old Nokia. Or maybe a phone in the village. And that's about all that they have. And so it's a great story from a customer in the Philippines. It's the International Rice Research Institute. This is a magnificent research institute. These guys have 70,000 strands of rice in their freezers. They can grow any type of rice that they want to. And their target is to make the life of the poorest farmers around the world better. And targeting, especially in that world, women and children that have no other ways of income than actually growing rice. So one of the systems that they've built, based on their knowledge, is how to apply fertilizer at the right moment in these small patches of land that these farmers have. And they built a digital system. You know, nobody actually wanted to access that digital system. Why? Because they didn't have web pages. They didn't have computers. These farmers don't have access to that. And the big success of actually the system that they've built is to put a voice interface against it. So what the farmer can now do, he can go to the village phone, call this number, select from 27 different dialects, describe their patch of land in a sort of fuzzy way. Machine learning goes off, comes back, describes exactly how much fertilizer to buy and when to apply it. Yeah? And then the farmer actually has good advice. This apparently reduces the amount of fertilizer by 90% and doubles the crop yield. The big success of this overall system is putting a natural interface against it, using voice. Now, we've been gaining a lot of experience, of course. Definitely with the launch of all the Echo devices. It's been a great help to us at Amazon to really understand how people want to use voice. Yeah, because this is a learning curve as well. So if you look at these devices themselves are actually not that terribly smart. No, the smarts is not in the device. Yeah, so if you look at the device, it has a speaker or a set of speakers. It has some speech synthesis hardware in there, wake word detection, and that is all that lives in that device. Everything, all the smarts of these devices live in the cloud, in the Alexa voice service. Yeah, so there's two parts of the whole software platform of Alexa. On one hand, it's the Alexa voice service, which basically manages automatic speech recognition, natural language understanding, figuring out which skills to trigger, and then talking back to our customers or managing their home automation devices. And on the other hand, the Alexa Skills Kit, which allows you to build very unique skills triggered by utterances of the user. So if you take a quick look at sort of how this actually works. So this is the Alexa voice service on this side, automatic speech recognition, natural language understanding, triggering the skills, and text-to-speech. So Alexa, or the device figures out the wake word detection, yeah, then captures the speech that comes after that, sends that over to the Alexa voice service, goes into automatic speech recognition, which comes back with text, pumps that into natural language understanding to figure out what is the intent of the user, and then use that intent to figure out which skills to trigger. The skills run, come back with a speech directive, and then text-to-speech actually creates the audio file that is sent back to the Echo device, and which is then presented to the customer. So all the smarts live in the cloud. This is a pure cloud service. And actually, the ASR and NLU components is something that you find back in Lex if you want to build your own. And text-to-speech is Poly. So in essence, you can build your own Alexa system if that's what you would want to do. Yeah. Alexa voice service is not something that is unique for Echo. Anybody can integrate the Alexa voice service into the devices that they have. And whether it's Harman Kardon or Sonos into their audio devices, or whether it's Hyundai and Volkswagen and Mercedes-Benz and Ford that are all putting Alexa in their cars, everybody is capable of putting the Alexa voice service into their devices. And also you. It's not just limited to these device manufacturers. If you're a hobbyist, you can actually put Alexa into anything. This guy, for example, put it in Billy Bass.
Alexa, what's the weather?
Currently, in Cambridge, it's 45 degrees with showers. Tonight, you can look for rainy weather with a low of 43 degrees.
This is amazing, isn't it? You know what's more amazing? This is a hobbyist that did this just for fun. So the CEO of Billy Bass sees this, and what does he do? He just extends the device that now we can make a Bluetooth connection from any Alexa device or any Echo device to your Billy Bass that you have hanging on your wall somewhere. And you can have it actually have the mouth move on anything that Alexa is saying on the device. It's actually really cool. So, but this shows that it's just cloud software, cloud service that you can integrate into any device that you have, or any other software component. Now, I think this is broader than just voice, but voice is important. Yeah, I think also when you think about sort of our environment, just like Billy Bass, all of our environment is going to become active. And we really see quite a few of these things, although sometimes I'm not really sure whether it's the right way to actually sort of interact with our environment. I don't know if you guys seen these internet-enabled toothbrushes. Basically, you hold up your cell phone and you're brushing your teeth. And you look at your phone whether you're brushing your teeth right or not. Yeah? I'm not really sure whether the cell phone output is actually the right way to go. Maybe some haptic feedback would be better in that particular case. Or if you set energy rules for your house, yeah? If you really have to look at night at a graph about your energy usage during the day, it doesn't really change behavior. But what about if you have a wall clock that goes to green when you are meeting your energy usage goals? Or, more importantly, going to red if you're violating them? That will change behavior. Yeah, and so it's not just voice that will be the interaction with the environment. Yeah? It is many other pieces that will all become active. And things that you can't even imagine yet. When GE puts Alexa into their fridges, yeah, which they've done, that creates a whole different interaction pattern with your fridge. It's very interesting. And so another area that Alexa is pretty strong at is home automation, where it can discover all the home automation devices in your world, it can connect to them, it can manipulate them, and suddenly, believe me, when I now walk into my house, and actually I have to walk over and flip a light switch, you get annoyed. Yeah? I want to be driving home in my car, and I say, hey, Alexa, open the garage door, turn on the porch lights, set the temperature to 20 degrees, and start playing Red Hot Chili Peppers. Yeah? And that's what you want to do. You no longer want to actually go around your room and flip all these switches to get all these lamps on. No. Once you're used to a more natural way of interacting with your environment, you will not go back. Now, next to home automation, I think there's another area where we have lots of devices that annoy the heck out of us. Yeah? At least me. Yeah? And that's your comfort room at work. Yeah? I don't know if you've ever tried to connect your laptop to the presenting whatever device that you have, yeah? Or find a printer. Yeah? And that's why meetings always start 10 minutes late. It's mostly because you have to connect your laptop, you have to dial into the conference system where you then have to first actually open up your laptop because you have to find the ID and then type the ID, do that 5 times wrong. I know, it's a nightmare. Yeah? And it's not just that, it's also the devices on your desk. Yeah? Much of the devices on my desk, I always need to use multiple devices. When is the meeting starting? You have to grab over my phone. I'm not using a phone. Really, do I have to use the phone for this particular case? No. And so we've been thinking then about if voice is this natural way of interacting in your home and home automation and things like that, why don't we build something that you can actually use at work as well? And so I'm very happy to announce today that we're launching Alexa for Business, yeah? which is a fully managed service for having many Alexa devices at work, to manage them, to manage the users, to manage unique skills that you may have at your work, both generic skills for depending on the devices that you have, as well as maybe skills that are uniquely developed for your business itself. So, of course, one of the first places where we've been working on is making sure that Alexa works really well in conference rooms. So there's been integration with Cisco and Creston and Polycom. They've all have the integration with their conferencing system so that you no longer ever have to type in a conference ID. You just say, hey, Alexa, start a meeting. because they know which room you're in, and they know which meeting should be taking place there. Also, integration with all sorts of other devices in and around your conference room. If your administrators have set up Alexa to actually really make use of all the devices there, you can dim the lights, you can lower the blinds, all these kind of things are suddenly available for you in your workplace. Or there's a great startup called Team. They do conference room management, and the integration with Alexa for Work, for Business with Team allows you to quickly find another conference room if the one that you're in is too small, or maybe it's occupied with another team. Also at your desk, so it's not just in the conference room, at your desk you can now have Alexas as well, of the Echoes as well. And you can do the usual things that you can also do in the conference room, join my meeting, call this individual. And the cool thing is that we actually give you a mechanism to merge your home Alexa environment with your Alexa for Business at work, meaning that you have access to all the private skills that you've set up for your own use. You can actually make use of those at your work as well. So you immediately get all your Spotify and your Amazon Music and things like that on your Echo device at work as well. Meetings are an important part of our business. So there is integration, which Alexa already had with Office 365 and G Suite. And now starting today, we also have support for on-premise Exchange for all Alexa for Business users. And so you can actually get access to all your calendaring and scheduling and meetings and things like that. Yeah? Also integration with a lot of other well-known software providers or service providers at work. RingCentral has PBXs, so you can get access to your voicemail and things like that. Integration with Salesforce, so you can ask questions against it. Concur, which probably holds your flight information and your reimbursement software. If you use SuccessFactors for HR, there's skills that integrate with that. Splunk has built a number of great skills, such that you can actually access your Splunk environment that runs in EC2 to actually ask questions against it using voice. Of course, at AWS, we've done it as well, so you can get access to things like CloudWatch and other information. Acumatica is a software, cloud-based ERP system that you can actually query for your voice. So it's interesting. You now have access to all these software pieces where you no longer need to go to web pages or anything like that. You can just use your voice to access them. And it's beyond just, let's say, just the office environment. The Wynn, the luxury hotel that sits a bit further down the strip, actually is putting Echoes in each and every one of the rooms in their hotel. Yeah, and with a whole set of private skills that actually really allow you to access all the capabilities of the room. So you can use voice to actually play music, to lower the blinds, to set the temperature, to control the TV. All these things now have a natural interface instead of that you have to run around with 5 different remotes to get these things done. So the service that we built in AWS is mostly sort of the management side of things, where you can provision and manage these devices. You know who is actually using which device. You can configure the conference rooms, access them from there, manage users, assign skills, which users are allowed to use which skills. You can build your own skills and extend that to which are unique for your business. And so there's a growing number of partners that build these skills for you. As well as that, we see already a growing community of actually companies that are already putting these devices to work. So WeWork is interesting because they have all these co-working spaces around the world. They're putting Echoes in all of the conferencing rooms that they have. Voynich, the same thing, 25 offices around the US, where they actually place the Echo devices, and they're big Chime users, both themselves internally as well as for their customers. And so the integration between voice and Chime is important there as well. So voice is the key thing here. Yeah, it's a natural way of interacting with your systems. And so if I think voice is the first disruption that will happen, driven by the capabilities of sort of the deep learning tools that we are giving you. It will also mean that you're going to build your backend systems differently. Now, much of the skills actually still interact with these sort of page-based systems. The next generation of systems will be built using conversational interfaces, because this will become the main interface to your systems. This is how you will unlock a much larger audience for the systems that you're building. And so then you need to build your backends differently. No longer thinking about just page-based output, but how does a conversation work here? How do these psychological frameworks for conversations, how do you translate that into different software components or different stages in how you interact with your customers? And so if you want to build conversations, and these systems are going to change, we are going to be your partner in that one. Because we are going to deliver those capabilities and those services to you that will allow you to build these systems of the future using AWS, and such that you can build conversational systems that will delight your customers. Now, it's not trivial. Yeah? I think if we think about new ways of actually building our systems, then it is important that we start thinking about our architectures differently. So if we go back to sort of 21st century architectures, definitely one of the first things is that they will have natural interfaces. But then when we think about sort of what is the rest of what's happening under the covers, what's happening in our backends, what kind of help do we get from AWS there, is of course there's a lot of help that we will give you. Lots of experience over the years. Now, I also want to think about, if I think about these architectures, these 21st century architectures, I think there's 3 different planes that you need to be sort of aware of. Yeah, one is the administrative plane of your systems. That's basically your deployment cycles. How do you deploy and manage sort of instances, containers, functions, whatever mechanisms you're using. Then there's the control plane, which basically manages the resources that you have deployed. And then there's the data plane that actually gives you the access to the resources. And each of those different planes play a different role, have different reliability requirements, may have different security requirements, and all of them are things that we see come back in all of our systems. And we'll talk a bit later about not just how we see this with our customers, but also, for example, how we do this at AWS. Now, I want to pull up an architecture that looks relatively simple. Yeah? We have a great customer in Kuala Lumpur called iFlix. They're a video streaming and TV streaming company that targets most of Southeast Asia, Middle East, and Africa. Very wide, very successful, relatively young business. And if you look at their architecture, this is the typical architecture that you would see if someone talks about a video streaming company. This is not the architecture. And if any of you have ever built a real system, you know that this is just way too simple. Because this is not how your real architectures look like. Yeah? There's a lot more. There is no eventing here. Where's the analytics? Yeah? How does this data flows from one area to another area such that actually your data scientists can get access at it? So let's do a little bit of a deep dive on what the rest of the architecture looks like. If you just pull out that sort of application subnet one, that actually has a whole set of subnets. There's a whole set of different VPCs that each have load balancers, that have nets, that have Kubernetes clusters for each of the applications that they're running. Each of them have databases associated with them. And they have a whole range of these applications running. And then, if you look at the next piece, sort of, if you want to do some level of control of your application, you actually need to move pieces through your organization. You need to move data. So this is their eventing infrastructure. And this is actually, if you look at this, many of these components in here are all AWS components. iFlix is a company that from day one has made the decision that if AWS provides this service, they will not build it themselves. And so they're really built around all AWS components. But still, their architectures are pretty, what I would call, extensive. Not necessarily complex, but extensive. And this is just how to get events out. Then you get to sort of, where do these events go? Yeah, and in real time, you have your S3 buckets that hold your raw data lake data. Then you have Athena-compatible buckets where they're running Athena out of. There's data imports, there's FTP input, there's log file processors, events coming back from their players. All this data is actually flowing into their system. Interesting enough, we help them with most of these, and the components that they really need to build themselves are relatively limited. And you see AWS services coming back everywhere, but these environments are extensive. And then you not even get to the part where they actually do the analytics. And where they actually have to create analytics, they have to go to their partners, or the telcos, or internal customers, or external customers. With each and every one, AWS helps them, but still, these are extensive architectures. And then it's not even the environment that where their data scientists actually can experiment with this data. And then we're not even talking about other parts of the architecture like this one, which is how to ingest video data. And so with all of that, the kind of point I want to make is that our applications and our systems are pretty extensive. But AWS helps you in most of those places to control the complexity and keep things simple. But still, real architectures are a lot more than just that one marketing slide that you saw at the beginning. Now, for many of our customers, this is a challenge with all of the different services that we have. But we give you help with that. Yeah, we've launched, I think 2-3 years ago, a program called the Well-Architected Framework. And this framework has become extremely successful for many of our customers. Our solution architects have performed literally thousands of framework analysis at different customers. And we've learned a lot from that. And so where a number of years ago the well-architected framework was one single document, now it is actually a set of 5 different pillars with very deep advice and knowledge about operational excellence, about security, reliability, performance, efficiency, and cost optimization. And I really urge you to visit the well-architected framework because there's a lot of advice about how you can build very extensive architectures on top of AWS. And so next to these 5 very extensive documents, these guys have been really active and sort of using all the knowledge that they have and try to apply it to different areas. So next to the 5 pillars that are underneath the well-architected framework, they also have created lenses. And they started off with 2 of them. So basically how to apply the well-architected framework if you have a high-performance computing application or a serverless application. Now, well-architected framework is now also part of every associate level certification that you get. And we run a number of bootcamps a year to train others to be able to do these well-architected evaluations as well. Now, if you look at the well-architected framework, there's a number of principles, general principles that lay underneath there. Yeah? Stop guessing capacity needs. Yeah, this is something like an old-style approach, yeah, where beforehand you actually needed to figure out how much capacity you need. No, build your systems first and then try to figure out what's the best instance to run this on at that moment. Yeah? Cloud also makes that you can test your systems at production scale. It's not that you need to have this 5 servers in a corner which you pretend to be a production system. No, test it at whole scale. Use automation to make experimentation easier. Make use of CloudFormation and other declarative tools like Terraform to lay out your infrastructure and allow that then to sort of instantiate new versions of your production environment to actually experiment with. Make sure that you understand that probably the system that you're building now is not going to be the same system that you're going to be running 6 months or a year or 2 years from now. Because business requirements may change, scale may change, reliability and security requirements may change over time. Make sure that you can evolve your system over time. It also has gone for Amazon Web Services itself. I remember first days of Amazon S3 with doing the architecture discussions there. We'd try and figure out sort of what would be the number of objects in this service about a year from now. And just for the heck of it, we put 2 extra zeros behind it. We blew through those numbers in the first 3 months. And almost with every order of magnitude or 2 orders of magnitude of scale in your service or in your software, you will need to revisit your architecture. The one thing we did know up front with S3 is that we were not going to run the same software 2 years, 3 years, 4 years later. That it needed to be able to evolve. That you needed to decompose into smaller building blocks so that it could evolve these independent building blocks over time without actually needing to be having to change the overall system in one go. And as I talked earlier about driving your architectures with data, and actually use game days. Just break things a lot, if possible. One particular pillar that I'm really excited about is the one in security, because I think if there is something that is really important today, is security. Yeah? Protecting your customer should be your #1 priority. Without that, you don't have a business. Yeah? This comes before any feature development. At AWS, it will forever be our #1 investment area. Protecting your customers and your business should be your #1 priority. So, fortunately, well-architected security gives you a whole set of best practices to follow. Yeah? Implement a strong identity foundation. For example, go for a minimum privilege, for least privilege. Yeah, so I know that once we start building our system, in general, everybody gets root privileges to do everything that they can do. That is something that over time you have to reduce. Basically, start taking away IAM roles until you can no longer do your job. Yeah, because least privilege is a very important principle in keeping your system secure. Centralize privilege management to avoid long-term credentials. Make sure that you have all the tracing and auditing tools ready. And much of that, automate your security processes. Because us here in this room are still the major vulnerabilities in terms of security out there. Protect your data at all costs. And make sure that you are prepared for things that can go wrong. Yeah, because sometimes they will. And if you're not prepared for that, you need to have your playbooks and your runbooks ready. And I want to come back to this protect your data in transit and in rest. Because I believe we've not taken encryption serious enough. Yeah? This is a quote I like to use. Yeah? First of all, nobody wants to see me dancing, so that is good anyway. Yeah? But you should encrypt, like everyone is. Encryption is the only tool you have to be absolutely sure that you are the only one who controls access to your data. And maybe 5 years ago, these tools weren't easy enough to use. Today, that's a whole different story. Encryption is integrated in almost all of our AWS services and ready for you to use. Yeah, 5 years ago, 6 years ago, we were still discussing whether HTTPS was too expensive. Now every consumer service runs over HTTPS. And so encrypting your data, both in transit and in rest, should be your default behavior. And we give you all the tools for that. You know, take a look at the signal-to-noise toolkit, SNN. It's a very lightweight implementation of TLS. That doesn't come with all of the millions of lines of code that sit in libSSL. Make use of that. You can encrypt it between your load balancers, between your instances. You encrypt traffic between your instances and all the servers that you're using. You can encrypt the data both in rest, and you can have us generate the keys for you, or you can bring your own keys. For example, Redshift encrypts by default every data block with a random key. That whole set of random keys is encrypted with a master key. We can generate the master key for you, or you can bring your own master key. Yeah, and with KMS, you can be assured that you are the one who controls your access to your keys by using both IAM as well as CloudTrail to make sure that you have full control over your keys. There is no excuse anymore to not use encryption. At minimum, encrypt personal identifiable information of your customers and critical business data. You have to encrypt because the threat models make sure that you can protect your customers and your business at all costs. And I like to believe that security is all of our jobs now. It's no longer the security team. Yeah, if you run continuous integration and continuous development, you have to make sure that everyone is actually now a security engineer. Yeah, this used to be your security team, but central in your security team will now be developers. You, as developers, have to become security engineers. It's all of our tasks to protect our customers. And maybe in the past, when you had a 3-month development cycle, you could have a review afterwards by the security team engineers. That's no longer the case. We move fast. We do 20, 30 deployments a week or per day sometimes. So this pace of innovation really needs to meet pace of protection. And the best way to do that is to use automation. Now, the good thing is we help you with that, but there's many places in your development pipeline that you need to start taking care of security. It's both the security of the pipeline, so make sure you have strict control over who has access to your build servers. Yeah? Make sure that the build servers have CloudTrail enabled. Make sure that you know exactly how these are operated, that they can't be compromised. And then security in the pipeline, make sure that every update that you make to your source code is actually validated, do code analysis on them, and then integrate that into your process. This is a typical continuous integration development pipeline, isn't it? Version control, the CI servers, deployment servers, different staging. This is how they should look like. Each and every piece should get security integrated into it to make sure that the software that you're developing is as secure as that you can make it. Yeah, and when do you need to do that? You need to do it pre-event, before you actually start deploying, and actually afterwards. You also have to have a set of rules for what do you do after that you've deployed. Definitely, if you can find out that sort of critical API changes, critical API usage has changed. For example, any changes to IAM need to be manually inspected. You need to figure out why did we make these changes. Any new set of libraries that got added to your deployment cycle should be audited. Yeah, and when should you do this? Well, whenever you make a change, maybe on a daily basis, maybe on a framework basis, you make sure that they always do this. So with all of that, we give you a lot of help with this automation. Yeah, you can make use of Trusted Advisor to give you static analysis. You can make use of Amazon Inspector, which has a whole set of vulnerability libraries that can continuously inspect the software that you're deploying to. Meaning that if you do continuous deployment, you can have Inspector continuously validate your environment to make sure that you can continue to meet the compliance regulations that you're probably subject to. Macy and GuardDuty make use of machine learning to either inspect your data and find personal identifiable information in the access patterns there, or GuardDuty sort of really protects sort of the identities and the access to your systems using machine learning about learning what are normal patterns for your usage and then find anomalies in the future and notify you of those. So we give you lots of automation tools. One of my favorite ones is actually config rules. Yeah, because config can sort of discover your whole environment, all the tools and all the services and all the resources that you're using, and then can start building an audit trail about all the changes that you're making to the resources that you're using. And you can get streams out of that, you can get SNS notifications, you can create snapshots comparing to how did my system look 2 weeks ago and compare it to now. This is a very important tool, often overseen by many developers, but please start making use of this because it will track all the changes in your environment. CloudTrail, similar. CloudTrail will log every API call to every service and then put it in a secure bucket in S3, where you can actually do analysis on and put alarming to. So we give you all of these automation tools. Use them. Because the more you can automate around security, the better it is. So how has development changed over time? Definitely, you have to be more security aware. I think development also has become way more collaborative. Yeah, where you work together with many different teams, not necessarily in your office, maybe around the world. I met one CIO yesterday who said, well, I'm not really a technologist, but I have 30 teams, 30 Scrum teams around the world collaborating together, which I thought was a real challenge for her. More languages. I think 5, 6 years ago, Java, C++, and some others were dabbling, maybe some Python. Now, there's a whole slew of languages to choose from, and we're moving much faster. More services to integrate. More different places where we're actually developing from. And QA and operations are deeply integrated into our systems. Now, if you build systems, if you develop in this sort of fast-changing development environment, you need help. And I think CodeStar and all the CodeStar tools that we developed in the past year really, truly help you in that world. But I think there is something extra that we needed to do for you. I believe that every great platform has a great IDE. And I'm happy to announce today the general availability of AWS Cloud9. Yeah? Which is a fully managed cloud IDE for writing, running, and debugging code that is actually pretty spectacular. And to actually show you more of Cloud9, I would like to invite on stage Claire Ligiori, Senior Software Engineer at Amazon Web Services, who's going to talk to you more about Cloud9.
You ready, Ankur? Let's do it. Hi, I'm Claire Ligiori. I'm a software engineer in AWS Developer Tools. And with me here today is Ankur Agarwal, the product manager for AWS Cloud9. We are super excited to be here on stage at reInvent today. And we're going to give you a quick demo of Cloud9. We're really excited to show you everything that we love about this IDE. So let's get started. This is AWS Cloud9. This is Ankur's Cloud9 environment, which we're able to pull up on any browser, like on this computer on stage. Ankur and I have been working on some side projects together recently, which I want to walk you through. We've been working on some applications to build applications that help us to throw team parties for the Cloud9 team. On the left panel of this screen, you can see we have a DJ app where people can vote on the music they want to hear at our team parties. And there's a trivia night app preloaded with some AWS trivia for our team trivia nights. On the right-hand side, you can see the Cloud9 code editor with some of our project code open. Cloud9 also has a full terminal built right into the IDE. I personally really like to customize my IDE, so I always go in and change the theme. I like this dark theme. Ankur likes it a bit lighter. I also always change the key binding. Emacs is the obvious right choice here. I'm a die-hard user, but Ankur likes the default. The other thing that I really like about Cloud9 is the number of languages and syntax highlighters that come pre-installed. We've mostly been working in JavaScript and Ruby, but we've also been experimenting with Python and Golang. So let's jump in and run one of these applications. We're now going to run the Trivia Night app right in the IDE. And then we can go and preview this running application. So without having to install Ruby or Rails on the stage computer, we're able to jump in and make sure we've got the right AWS Trivia installed. So that was our Trivia Night app. We also have our DJ app where people can upvote or downvote songs for the party. So let's switch over to the terminal. We have the list of songs that people can vote on stored in a file in S3. So Ankur is now using the AWS CLI to download it. The CLI was really easy to get started with because it comes pre-installed with all of our AWS account credentials. So let's go ahead and open up that file. And Ankur, I think this is your personal playlist. That's a lot of Britney Spears. I love Britney too. I hear that she has a great show here in Vegas. And another thing with a fantastic show here in Vegas this week is serverless applications. So Ankur and I, for our side project, we've been working with serverless a lot, and we're really excited about the possibilities here. Cloud9 really helped us to iterate really quickly on the Lambda functions we've built. Right here from within the IDE, you can see all the Lambda blueprints, which helped us get started really quickly. I want to show you a sample Lambda application that we built that orders food for our party. Our big plan here is that we'll be able to place an order to our local pizza place at the push of a button. But for now, we've got a proof of concept that orders pizza. So what Ankur is doing now is he's importing this Lambda function into his Cloud9 environment. And now we're looking at the code that orders the pizza. So let's go ahead and jump down to the order details. So because this is a proof of concept, we currently have our order hard-coded to 2 pepperoni pizzas. So we've got that set. But we want to throw a party here at reInvent. So we're going to change the address from Amazon headquarters to the MGM Grand. And we should probably test this before we actually place an order. So we'll set a breakpoint and run the debugger. We're going to run this with the run local option. What that means is that we're actually testing out what our code would do if we ran it directly in Lambda. So let's see how we did. So we'll turn on debugging, go to run. So our debugger hit the breakpoint. So we'll scroll down and look at the variables, make sure we made the right change. Perfect. So you can see the MGM Grand, we have the right address. So we'll go ahead and resume this and let it run. Awesome. So our test order was successfully placed, but of course this was just a test. Before we push this to production, I want to go in and review Ankur's change. So Ankur, can you share your Cloud9 environment with me? This is one of my favorite Cloud9 features. Right now, Ankur is going in and giving me full access to his environment, so we can pair program together and review code. Great, so I'll go in and get in my environment. OK, I'm logged in. So what you're seeing now is my screen is on the left-hand side with my blue theme, and Ankur's is on the right-hand side in the light theme. You can see our initials on the upper right corner of the screen, which means we're both online in this environment. We can also hover over each other's cursor and see what code we're looking at. Ankur and I use this a lot to pair program. So I can go in and highlight some lines on the screen, and then they show up on Ankur's screen in purple.
Wait, I'll do that.
OK.
Finally, my first chance to write production code. Yeah? Whoa, small characters. OK, fine, what do you need to do, Claire?
So what I want you to do is, Ankur and I use this to pair program a lot. Is there a change that you want to make?
Oh yeah, there needs to be beer with the pizza.
Obviously, obviously. So one of the things that Ankur and I like to do is chat within the Cloud9 IDE.
OK.
So go ahead on the right-hand side of the screen. Go ahead and tell Ankur that you're going to make a change.
OK.
So Werner says, hey, Ankur, I have one more thing to add. I wonder what that could be. And Ankur says, go for it. So Werner, on the left-hand panel, go ahead and make your change.
Wait, I'm getting old.
So as Werner's typing, you can see that his changes are showing up on Ankur's screen on the right-hand side. And Cloud9 autocomplete is popping up, helping him to fill in the right order parameters. So it looks like he's added our 2 beers.
OK, thank you.
Thanks, Werner. So Ankur, now that that's done, go ahead and push it to production. So what Ankur's doing now is he's taking the changes that Werner made in our local environment and deploying them to Lambda. And then we can go and actually run these changes, actually invoke this function. So we're going to select Run Remote and really place our production order. Awesome. So our production order was placed, and pizza and beer are on the way. Thank you so much. Please check out AWS Cloud9 and the console later today. Well, that's fast delivery.
Thank you guys for a great demo. I left the beers downstairs, backstage. That's how I enjoyed them.
Thank you.
Thank you. Cool. Great IDE. Fast to deploy, deep integration with all the different services, pair programming. And what I really, really like in Cloud9 IDE is the ability to debug your Lambda functions. There's no other tool out there that gives you that support for Lambda. So, also the deep integration with all the CodeStar tools. Yeah, so it's not just lives that in its sort of isolated environment, but CodeStar, pipelines, deploy, commit, build, all of those are integrated in IDE. So, I just lectured you on security. Now I get to lecture you on availability. So we all want to build highly available systems that are up 100% of the time. Yeah, that's where we build our systems for. Yeah, that's how we build them. We never assume that something bad will happen to them. But if you remember this quote from many years ago that I did, it said, everything will fail all the time. Yeah, and actually, after the last failure, I promised to get a tattoo. I haven't done that yet. Yeah. I'll wait for the next failure, which will happen. We don't know when, but it might. So if we think about availability and sort of the rules that, or the best advice that comes out of the well-architected framework, we talked about it earlier, test your recovery procedures and stop guessing capacity. Those two were sort of general principles in a well-architected framework. Try to make your recovery as automated as possible. If you use horizontal scaling of smaller components, the likelihood is that you can build much higher available systems. Yeah, and then actually manage those changes through automation. Let's go take one step back and talk a little bit about sort of the fundamentals around reliability. So you all heard sort of the famous 2 nines, 3 nines, 4 nines, 5 nines. Basically, that sort of indicates the amount of successful running time over the time that your application should have been running. And so the way that you architect your systems, you can have a sort of educated guess about what sort of the minimum bound is of sort of the availability of your application. Of course, if you're lucky, availability is 100%, but based on your architectural principles and the architecture that you've built, you may have a lower bound that you can achieve. Dependencies play an important role there. Yeah? If you have one component that has 4 nines availability, 99.99, and you have another component that has 4 nines availability, and you have a hard dependency between them, the overall system, the best it can achieve is 99.97 in terms of availability. Now, that is if you have hard dependencies. So figure out exactly what do you do with your dependencies and how do you depend on them and what is the effect of your overall system. If you have redundant components, that becomes a lot better. Because actually the rules there is that you basically take 100% and you subtract the product of sort of the failure times of each. So in terms of if you have 2 4-9 systems, you get 100% minus 0.01 times 0.01, which means that if you have 2 redundant components that each have 4-9 availability, the overall availability of your system rises to 5 nines. So redundancy is a very important tool to create higher available systems. Now, if you think about availability, there's a number of great set of advices that come back in the well-architected framework. And these are actually, many of those are principles that we apply within AWS ourselves as well. For example, fault isolation zones. Yeah, there's the minimum one of that is something that we call cells, others call it shards, but where actually even within your application, you're going to build cells that are independent of each other. You use a resource ID or whatever to spread your traffic or your access over the different cells and make sure that inter-cell communication is kept to a minimum. That means that the blast radius of a failure is actually limited to that particular cell. The next level of sort of fault isolation is AZs, which we give you, where AZs are independent of each other, but still have networking that actually allows you to do sort of synchronous replication between objects in the different AZs. And then, of course, the absolute best sort of isolation is that of regions. Regions are completely autonomous. And there is no sort of control and data planes that actually span multiple regions. Thinking about sort of the control planes, a number of our services, for example, EC2, have a control plane that spans multiple AZs. But it allows sort of the API calls to be filtered per AZ. That is, there is a failure going on in one of the AZs, you can still sort of access all the resources in the other AZs without needing to be bogged down by the fact that your control plane in one of the AZs may be actually sort of slowing down. So think about that when you build control planes that actually have to span multiple AZs. In all of this, distributed systems best practices, of course, always come back. I'm a real stickler for this to make sure that both our customers as well as our engineers internally stick to these distributed systems principles. Yeah, you have to throttle if you get overwhelmed. Don't try to do all the work. And on the other hand, if you're a client, make sure that there is retry with exponential failback. If you see errors coming back, all the AWS SDKs do this, but if you actually build your own access mechanisms, please take care of doing exponential fallback when you see errors happening. Don't try to overwhelm the service with extra requests. If you build your service, make sure, if you know that you might not be able to actually handle this request, fail fast. Release all the resources that you need. Yeah, and for all of those constant work, circuit breakers are important. If you notice that one of your downstream services is giving you troubles and it's not a critical service to use, flip a circuit breaker, take them out of the loop. And make sure that sort of you minimize what I would call bimodal behavior. And that is your failure behavior, sort of in your recovery paths. If they are extensive, yeah, avoid that your services end up there. Fail fast. Make sure that sort of you don't do massive recovery work, yeah? But take, for example, a recovery-oriented approach to actually availability. There's a great story by, I think, Van Zetta, who actually is one of the Multics engineers. You probably are way too young to remember what Multics is. It's a very famous operating system built at MIT, I think in the 60s and 70s. And so one of the engineers wrote and said, half of the Multics code was error recovery code. And Dennis Ritchie, one of the original developers of Unix, replies to that, says, oh yeah, in Unix, we've taken all of that code out and we replaced it with one function, panic. And then you would scream down the hall like, reboot the server. That was sort of their approach. However, it made sure that in isolation, you could actually have very fast recovery, because actually rebooting the machine was probably a much faster recovery path than going through massive trees of error handling code or failures that you'd never seen before. Now, in all of this world, if you really want to, you have to apply automation as well. We just give you access to canary deployments in Lambda. That means that a subset of your customers get exposed to new code. Blue-green deployments, basically you can have two fleets next to each other where you can flip back and forth, or maybe have a percentage of your customers flow them to the new code. Feature toggles is the mechanism where you deploy the new code or the new system, but you don't enable the new code. And you slowly start toggling on features one by one to see how they impact your customers. And of course, when you do deployment, deploy them to the fault isolation zones in sequence, not all at the same time. Now, in all of this, I like to believe that it's business rules that drive availability choices. As much as that we all want 100% available systems, they actually cost money. And so it must be a business decision what kind of architecture you're going to be using to help support the availability. Now, if we look at systems, for example, that have two nines, they basically have a single instance and a database, and maybe backup into S3. If this instance fails, and maybe you even run the database yourself on the same instance, the best availability that you can get out of this is 99.9% 99.9% availability. You should imagine that if something goes wrong, it takes you 30 minutes to figure out what went wrong. It takes you 10 minutes to deploy a new stack, and then 30 minutes to probably load the backup from S3. And so if you have 4 of these failures a year, that would take you sort of to somewhat, 4 times 70 minutes, 280 minutes. And that would sort of have an upper limit of 99.9%, but probably you'll do some software deployment to a single instance, so you take it out a number of times a year. Best numbers, probably bottom line, is 99.9%. It's cheap, though. And there might be quite a few services that you have, or quite a few applications that are fine with 2 nines availability. However, if you want more, maybe you need 3 nines. In that case, you need to run at least in 2 availability zones. You may run master-slave between the databases. The master lives in AC1, so all updates flow through AC1. If something goes wrong with one of the AZs or one of the stacks, you basically fail over the master to the other availability zone, and that's sort of, that's then your failure handling. Again, diagnosis, 30 minutes recovery, 60 minutes in total, probably. And again, if you have 2 of these outages a year that actually take the whole system down, you actually are able to actually get 99.95 out of this one. Now, if you want to go really, really sort of extensive, you might want to deploy to 3 availability zones and actually be prepared for if you lose a system in an availability zone, to still have 100% capacity available for your application. That means you have to deploy 50% of your capacity statically in each of these zones. Maybe in this particular case, you will use Aurora, use multi-master, so that you don't need to worry about cross-AZ communication for your databases. But if you lose one, then you still have 100% capacity available in the 2 other ones. So that means that probably your failures are going to be seriously limited. The complete failures, where your whole system is offline, is going to be seriously limited to just a few minutes a year, and you can achieve 4 nines. Now, if you want to achieve 5 nines, you can't do that with just one single region. You actually need to be able to make use multiple regions. So a 5 nines will basically deploy this active over 2 regions, make use of Route 53, and what you're going to be using here is DynamoDB global tables. So that gives you synchronous replication of your data between the different availability zones, and if you would leave between the different regions, and if you would lose a complete region, you will still have everything in your application available. So this really will give you sort of the ultimate in availability design. And it's still the business rules that decide whether or not you're willing to make these kind of investments. That has nothing to do with AWS. In all the world, you will actually need to have your business make decisions about what kind of architecture you want to run to support the kind of business that you have. The cool thing is with AWS, we give you all these mechanisms and all these tools to implement any availability scenario that you have in mind. And if you look actually at the AWS services itself, you can see that there's differences between the control planes and the data planes that are available there. So if you go to the well-architected document on reliability, you will see some of these numbers, 3.5 nines, 4 nines for KMS in terms of the control plane, I'm not sure whether all of you can see the numbers over there. Actually, Route 53, the data plane, has 100% availability. Why? Because with all the spreading out of all the capacity, distributed capacity around the world, we can guarantee they are designed for 100% availability. IAM and KMS both have 4.5 nines of availability because they're such crucial services within all of the operations of AWS. So if you are interested in these numbers, check out the reliability pillar of AWS, of the well-architected framework. In all of this, testing plays an increasingly important role. Yeah? Test, test, test. Break everything that you can and see how your systems respond to it. Within that, game days play an important role. Yeah? Just break things and just have a whole day where you do nothing else but try to break your systems. Many years ago, we tried this for the first time, not at AWS, it's PDAT in Amazon.com, where we took a data center out, and we thought we were really good at that. Well, all the things you learn when you have these major failures is very interesting and very important. All of this has resulted in a whole set of new theories and practices, and that's called chaos engineering. It's practiced by many organizations around the world. And I'm very happy that Nora Jones, the co-author of the book on chaos engineering, is willing to come and talk to you. She's senior software engineer at Netflix and has great experience in chaos.
Thank you. Thank you, Werner. Good morning, everyone. This is a typical screen that you see when you log into Netflix Now. You might see a trending now row, a popular on Netflix row, and a continue watching row. And if you're like me, your continue watching row probably contains Stranger Things Season 2. So let's take a look at this continue watching row. Say, for example, that we weren't able to load what you had been watching previously. That's a part of our system. And so that failing probably shouldn't result in an error. It should result in a fallback. Maybe a fallback that we just don't show you that anymore. Or maybe a fallback that we show you something else instead. What shouldn't happen is that service failing shouldn't result in a streaming error. And so we exercise these fallbacks like this one pretty regularly through chaos experiments at Netflix. Now you may be thinking, couldn't I just beef up my known forms of testing and get that out of the box? Do I need to do chaos experiments as well? So let's talk about some of those known forms of testing. So one of them is a unit test. And a unit test is where we take a single component, we look at the input, and we make sure the output is OK. Given input X, I expect Y to happen. But we're testing a known here. We're testing things that we expect to test and we think to test. And another form of known testing is integration tests. Now, integration tests are also testing knowns as well, except we do it between components. Given input X, I expect component A to output Y. And then I expect component B to output Z. We can also do it on a service level, too. Components in services talking to other services and knowing our expectations from there. Now that we've described some known forms of testing, let's talk about chaos experiments. So you'll notice they look a lot like integration tests. Except here, service C to service D, we have the option to either add a failure or add latency by adding time in between our calls. Two troubles that trouble our distributed systems pretty regularly. And so you'll notice here that we dropped the word testing and that we're calling it experiments instead. And that's because here we have unknowns, right? We assume that we're resilient to these failures. We assume that we will be fine, we will provide our fallbacks. And so here it's resulting in unknowns if we're failing these calls or if we're making them latent. So now that we've defined chaos experiments and we've talked about known forms of testing, what's the discipline of chaos engineering as a whole?
The discipline of chaos engineering is experimenting on a distributed system in order to build confidence in the system's capability to withstand turbulent conditions in production. So chaos engineering is not meant to replace unit and integration tests. They're meant to work together in harmony to give you the most availability possible in order to ensure that your customers have a great experience and that your business stays up and running. In my role as a senior chaos engineer at Netflix, it's my job to expose the chaos in our systems before it renders your home screen unusable and before it renders you unable to watch Stranger Things. Most recently, I've had the opportunity to work on the chaos engineering book with my colleagues at Netflix, Casey, Aaron, Lauren, and Ollie. And we talk about how we perform chaos at Netflix scale, but we also talk about how you can apply it to other types of businesses as well, to early stage startups, to companies of the scale of Netflix, and to different types of industries as well. I've had the opportunity to do chaos at startups and do chaos at Netflix scale. And I want to talk to you about some of my experiences introducing it at a startup. So I worked at an e-commerce startup, and in my second week of work, we had an issue that caused the site to go down for an entire day over a weekend period. And we realized we could have caught this. We could have caught this through regular chaos experiments. So we decided to start introducing chaos. And we did this in the form of graceful restarts and degradation. Now, a lot of you may know of this as Chaos Monkey. And if you're running in the cloud, you should definitely be resilient to a single node or single instance failure. So what happened when we did this graceful restarts and degradation was that our system was already chaotic. We didn't totally evangelize this properly. We ended up bringing QA down for a week. Now, luckily, we had enough foresight not to do this in production yet. But we found issues that were inherent and that would have happened in production anyway if we hadn't done this. And so we started with an opt-out model, but then we moved to an opt-in model, right? And so we worked with teams, we worked with non-critical services that wanted to participate in chaos experiments, that were ready, that had a good steady state defined. And so we moved into targeted chaos. And at that point, the startup was trying to do regional failovers. And so we were heavily reliant on Kafka during these regional failovers. So we decided to start chaos testing Kafka. And we tried to think of ways Kafka could fail in these regional failovers. So we added experiments in the form of maybe changing the offsets, maybe partially deleting a topic or fully deleting a topic, maybe adding a bunch of consumers onto one topic. We had a bunch of different chaos experiments running, and we realized we weren't resilient to all these failure modes. And we were able to find that out before we did these failovers and before we brought these failures with us to other regions. So next in the startup, we were getting momentum, and we tried to move on to cascading failure. And so a cascading failure is when a failure in one part of the system triggers a failure in another part of the system, which triggers successive failures. So we tried to cause a cascading failure. A bunch of service teams and I got in a room together, and we had monitors up on the screen, and we triggered a failure. And we did cause a cascading failure, but we did not cause the one that we intended. What ended up happening was search stopped receiving timeouts, pricing wasn't handling that, and then Elasticsearch went completely down in QA. And again, we were still doing this in QA. But it was things that we would have seen in production had we not been chaos experimenting yet. And that was when I really saw momentum get up in that startup, and I actually saw a culture change. I saw a culture change from people not asking what happens if this fails to people asking what happens when this fails. And when I moved to Netflix, I was lucky enough that this was already the culture. Netflix is doing things differently, and they were doing it through failure injection testing. So service owners can actually easily add latency or failure. So that screen that we looked at earlier, the chaos experiment screen, we allow service owners to easily add latency or failure based on predefined criteria met and in different injection points and building blocks of our system. But what's important here, we realize, is safety and monitoring. With our failure injection testing framework, we had no way to impact how much traffic that we were affecting. And so we built a chaos automation platform on top of it that allowed us to determine how much traffic that we were impacting. And we called this CHAP. And we're working on it actively today. And so the way it works is that calls from service A to service B are behaving as normally. Now, at Netflix, our key business metric is whether or not you can actually press play. Now, maybe you see a screen and you're pressing play and nothing's happening. If that happens, we see a spike in that key business metric. And we call it SPS, stream starts per second. Or maybe the play button isn't even available at all, and in that case, we see a dip in SPS. But we always keep a watchful eye on this key business metric, SPS, when we're doing these chaos experiments. And so we look at our SPS, and then we calculate the smallest fraction of traffic possible in order for us to get a signal that the chaos experiment is working properly. So say, for example, in this experiment, we calculated 2%. 2% of traffic is what we needed to get a signal here. So we take that 2% and we split it in half. We route 1% of it into a control cluster, and then we route the other % of it into an experiment cluster. And in the control cluster, we don't do anything to it. We let it behave as normal because that's our control. And then our experiment cluster, that's where we can add our failure or our latency. And so that SPS, that key business metric that I was talking about earlier, we actively watch this during the experiments through automated canary analysis. And we look at our control graph and we look at our experiment graph, and we see if those deviate too far from each other. And if they do, we automatically short the experiment. And so this is a key safety mechanism in place when we're doing our chaos experiments. Because if the experiment shorts because we see an error, we're able to stop the experiment early, and the engineer is able to go offline and debug the issue without being under the fire of a pager going off or a customer seeing an issue. And so we're able to debug this before it renders Netflix unusable for you. So what's the future of this? So right now, in order to do chaos experiments, we had to meet with teams, we had to decide what good injection points were, we had to decide what good failure scenarios were, and it was taking a lot of time. You know, it would take a few hour meetings, and we decided that we needed to start getting smarter about this. Maybe we could come up with an algorithm that decided what the best chaos experiments were. And so that's what we did. We've looked at the entire system as a whole and started coming up with the chaos experiments on our own and automated them. And we're automating the criticality of them too. If they're a more critical experiment, we'll run it more often. We know this is something that needs to be run more often. And so we're in the middle of this right now, and it's been going great so far. It allows us to run way more experiments a day. It eliminates the meetings that we had to have before. And we're seeing a lot of issues that we're able to reveal before the customer sees them. So you may be thinking here, I need more chaos in my life. And you totally do. Everyone can and should be doing this. So if you want to learn more, you can go to theprinciplesofchaos.org to hear more about the discipline. The book that I mentioned earlier is also free online on O'Reilly. And if I can leave you with one final truth today, it's that chaos doesn't cause problems. It reveals them. Thank you.
Thank you, Noah. Yes, we need more chaos in our lives, don't we? Yeah, I love that. If you go back in time, which I often like to do, John Gall was a systems researcher in the 70s, and he had done a lot of research on what makes systems actually reliable and not. So he had come up with this principle, this only part of his law. His observation was that complex systems that failed were in general built as complex systems from the start. And so a complex system that works has invariably been found to have evolved from a simple system that works. And so you start off with building smaller and simpler components. And out of the aggregate, you can probably build your more extensive, more complex architectures. Because in the end, we will end up with more complex systems. So if we take a step back and think about how can you reduce the complexity on day one, if you remember the maintenance plane, the admin plane, the control plane, the data plane, if you compare, for example, RDS versus running your own relational database management system, in that RDBMS, you are responsible for all the 3 planes. Admin for deployment and management, to creating the instance, controlling that, controlling your database, and the data plane. In the case of RDS, the admin plane is taken away from you. We take care of that. Large parts of the control plane are actually removed from you as well. And so you continue to keep parts of the control plane in your world and the data plane. If you look at running your own NoSQL system, again, you're responsible for managing the reliability and the security of each of those different planes. However, if you run DynamoDB, no more administrative plane, and the control plane is sort of reduced to only telling us how many reads and writes you want. And then the data plane is again under your control. That's sort of where you interact with the service. So the more managed services you use, the less moving parts you have. And so if you want to build simple services, simple systems that can be reliable and secure, then you need to make use of as many managed services as possible, so that you don't have to take care of that. Now, we continuously roll out these services. So, for example, in here, and I may not have made many great announcements yesterday in Andy's keynote, but sort of on the sides, we've been launching all these other services. Did you notice that we actually launched a time synchronization service yesterday, so that you can keep all your instances in check? Did you know we launched Amazon MQ, which is an active MQ, managed active MQ service? And we continued, well, all of these components, we more and more roll out managed services so that you have to do less and less and really, truly can focus just on the business logic that you want to write. And whether it's coordination, whether step functions or ECS helps you coordinate your systems, or whether you make use of ALB or API Gateway, all of these tools are managed for you. And so the more you make use of these services, the higher the likelihood is that your system will be reliable, secure, and can scale. In all of that, there's of course the rise of microservices. And so I'm really happy that this is really taking a hold on, because I believe that these are crucial steps for you to build more secure, more reliable, and better scalable services. So in my eyes, what do microservices look like? It's basically scaling components down to the minimum business logic that has unique scaling and reliability and security requirements. Now, you may have heard about sort of that Amazon.com, the retailer, in 2000 went through a service-oriented architecture, re-architecture, sort of one of the first pioneers in there, and it was a great success over time. Actually, what probably we haven't never told you is that we'd gone through a few of these phases. The first one was core-grained services, and pretty quickly we'd figured out that we'd made a mistake. So one of the mistakes that we'd made was that in this decomposition of the monolith into smaller services, some of these had been data-driven. Basically, all the code that operated on the customer data set together in one service. And the same was for orders, and the same was for items, which is the catalog. And so in this service, the service customer master service set all code that operated on customer data. And that meant that one component had sort of the recognized customer service, so the login service, as well as the attribute service, and everything in between. As you can imagine, a login service gets hit on almost every page. The address book service only when you have to check out. So, but when you need to scale this, you need to scale it at the requirement of the login service, not of that of the address book service. And plus, it became a security issue as well, because now suddenly the component that manages the address book service also has access to your credential set, as well as the login service now has access to the address book service, which has no need. So decomposing this into smaller building blocks that each have unique scaling and reliability requirements improves your overall posture in terms of scale, reliability, and security. And improved fault isolation comes with that as well. All of this, I think, has been really taken off because of container technologies. Yeah? Both in terms of ECS, which has a deep integration with all of the different AWS components, and as well as now also Kubernetes. This Elastic Compute Service, Elastic Container Service for Kubernetes gives you this as well. And so container technology has become sort of the default mechanism if you want to build microservices. So with that, I'd like to invite Abby Fuller on stage, probably the only person who can make Wu-Tang Clan jokes and then explain containers for you with that at the same time. So Abby Fuller is Senior Technology Advisor at AWS and probably the world's expert on containers. Abby.
Hi, everyone. Thanks, Werner, for having me. I'm super excited to be here. And if you all are half as excited about the container announcements from yesterday as I am, we'll have a really great time today. So as Werner mentioned, kind of looking into how can you work with containers? And what we got yesterday was there's a lot more options for running on containers on AWS than maybe there used to be, right? So we have ECS, we have Fargate for ECS, we have Amazon EKS coming soon, and we have Fargate for EKS. So tons of options, but that's really a good thing. So we want to be the best place for you to run your container workloads however you want to run them. Kubernetes, great. ECS, also great. Want to use something else? Sure. Part of this power here for you is in those choices. It's being able to choose what works best for your workload, what supports you. How can you run something that just works? And what Werner mentioned is how can I get kind of the minimum viable system with containers? How can I get something that just supports my business logic where I have to do less and less of that undifferentiated heavy lifting? But the question that I'm always asking myself when I'm listening to these is, but how can I get started? How can I make this real? How can I choose the right tool for me? How can I put my fingers on a keyboard, leave this keynote right this second, but don't do that, and get moving? So to do that, let's rewind for a second and look at what we've built and why we've built it. The container space has been evolving for many years, from the orchestration to the automation to the layers themselves. And we've been running containers on EC2 from the very beginning. But what we got from our customers is that there were some difficulties for them. There were some pain points. There was a lot of that what we like to call heavy lifting. So we built ECS. And why would we build something like this? So managed platform for all of those pain points. So cluster management, container orchestration, with that deep AWS integration that Werner mentioned, which is basically, how can I get those things that make a well-architected app? How can I have someone else help me with that? How can I get a shared responsibility model and still get things like auto-scaling and load balancing and logging and monitoring? So that's what we mean when we talk about deep AWS integration. And ECS was a managed way for us to do that for you. Run your containers on AWS with a little bit less of that heavy lifting. And customers are not only doing amazing things with ECS, they're running mission-critical workloads. These are just a couple of them, and I'm actually really glad that the screen gets bigger and bigger every year, because I can fit more and more beautiful logos of all of you. And from startup to enterprise, companies in every imaginable sector on that slide are using ECS to run their applications. So let's dig into a couple of those customers. So containers are for everyone. So financial enterprises like Capital One use ECS to run their containers behind application load balancer for a faster pace of development, to make things a little bit easier, and to separate out their services. And it's not just about big enterprises, it's for startups too. So as some of you may be familiar with Segment, they're a marketing startup that collects data from sources like web apps and mobile apps, puts it through their system, and gets it out to places like business analytics tools and CRMs. So they collect all that data, but to do that, they process a ton of events. So they handle more than 160 billion analytics events each and every month. So that's up to, I can't do on-stage math like Werner can, but that's up to 270,000 events per second. So they have to do something, right? They can't be sitting at their desks and Segment and deploying all of these by hand, because I think that might be a ton of work. So they use auto-scaling to scale up to thousands of containers to handle that traffic when they need to handle extra traffic, but then to scale back down when they don't need that capacity anymore. And that breaks down to 25,000 tasks across over 300 services. But it's not just for event processing. So they also run their ETL jobs on ECS. So they collect data, they run it through roughly 500,000 short-lived containers a day, and put it into places like Redshift and Postgres. So that's 3.5 million containers spinning up and down a week just for ETL. And what ECS is letting them do is focus on what really matters for them, and that's their application. Because all that really matters, ultimately, the bottom line, is what can I deliver to my customers? But ECS is not the only way to run containers in production. We had a lot of customers that were running Kubernetes on EC2. And we've thrown this one around a lot recently, but more customers are running Kubernetes on AWS than absolutely anywhere else. One of those customers is Monzo. So they're a mobile-only bank. They're based in the UK. And they've been cloud native from the very beginning. So they're built with 350 microservices right on top of EC2. And for money, I feel like high availability is extra important. So I live in New York, and please don't judge me, but if I want to be able to buy a rainbow cookie at 2 o'clock in the morning, my bank's planned downtime should not prevent me from my cookie. So they have high availability at every single level of their infrastructure. That's from multi-master to hundreds of workers, all backed by highly available etcd. But safety is important too, so they use Direct Connect to peer between their resources in third-party locations, like payment providers, back to their AWS infrastructure. Plus, containers have let them scale their infrastructure with a really small and flexible team. So they've been able to use their infrastructure to their advantage. So they started with 80 services in 2016. They grew to 167 in 2017. And in 2018, they're on track to have 350. So they've been able to really keep their small startup team and that flexible mentality, but use their infrastructure to help support their rate of growth. But they have a quote that's been passed around the internet a lot, I think, and it said that highly available Kubernetes was not for the faint of heart. And that was a theme for a lot of our customers. Run Kubernetes for me. Help me do this. This is a technology that I want to use. Can I get a little help doing it? And that's what led us to create EKS. What's EKS? Managed Kubernetes for AWS. And there's a common thread here that I think started with just running containers on EC2 that brought us to ECS, that brought us to Kubernetes, that brought us to EKS. And that's run containers for me and let me focus on the application. But what if I could ask for more? Containers in production can be really hard work. As Werner mentioned, you end up with lots of moving pieces. And we want you to focus on what really matters, and that's delivering a really great experience to your customers. Remove that heavy lifting. Just run my application for me. Which brings us to Fargate and the future. So Fargate isn't a service, but it's an underlying technology that you can use to power your container workloads. That means no infrastructure, launch easily, scale quickly. Just take your task definition or pod, drop it into Fargate, add some resources, and away you go. But I want to make that future real, and I want it to be more than just a product announcement. So I'd like to preface this, by the way, saying that this is not the flashiest demo that I've ever done. And it used to be that I could come up here and I could create a VPC from scratch, and I could be, wow, look at how awesome I am. And that's not going to be like this. This is a real-life demo. So what I want to do is take something that you all might do at work, deploy an app, and see Fargate in action. So I'm going to start with my task. Waiting for my thing. Great. So I'm in the Fargate first run experience. I can add my container name. So this is pretty much very similar to the ECS experience. I add my resources. I'm adding a port mapping. I save it. Now I get to add my task definition. So I add a name. I tell it where to look for my container. I have to add my load balancer, because high availability is important. Go next. I save it. I wait a couple of seconds. So that this is going to deploy now. And then I'm going to click over. And you can see that my app is out there in the wild. So this is the Werner Keynote. So just like to let everyone know that there are just about 11 hours until the replay party. And that's what really matters on Thursday, right? So, woo! I don't know who the artist is either. So Fargate, for me, is less about the how and more about the how well. And all I want to do is I want to just run my workload. Nothing else should really matter to me. Don't worry me about setup or tuning or environment or images. Just run it. Fargate lets me focus solely on that workload, my user experience, and it lets AWS handle the heavy lifting, and that's really powerful for me. And Werner mentioned right at the beginning of today about building systems that would support you in 2020. And that's what Fargate is. How can I make the future not only real, but easier? How can I focus on what really matters? Delivering something really awesome to my customers. How can I iterate faster? How can I scale more easily? How can I do less work on the infrastructure side and more on just the running it side? That's my goal. No setup, no service discovery, none of those little bits and pieces. And it's a shared responsibility, right? So I want someone else to worry about them. I want someone else to know that they're working on all the internals. And I want to be able to build with a new primitive. Just my containers. But all I ask is that you build with a couple of things in mind. Secure, scalable, reliable, that's it. The future, and I think we're rocketing there really fast with services like Fargate, focuses on units of work, a function, a job, a container, workload first, full stop. Thank you.
Amazing. What do you think of the speakers? Let me not tell you that there are no rockstar female engineers out there. Yeah? At least I had no trouble finding them. Yeah? So something I catch on what Abby just said is that for me, how does the future look like? Yeah? Is all the code that you will ever write will just be business logic. Yeah? If you use these managed services and these managed environments, that is the only code you will write in the future. Yeah, CPU scaling will take care of Lambda and ECS. I/O scaling will be done by DynamoDB and Aurora Autoscaling. Reliability by Lambda, ECS, DynamoDB, Aurora Serverless. All of these components will take care of this for you so that you can focus on the true premise of cloud, which is you only have to write business logic. Now, serverless plays an important role in this as well. Yeah, this is really where you no longer have to worry about any server management. You have flexible scaling that you don't need to take care of yourself. You get automatic high availability of your functions out of the box, and you never have to pay for idle capacity. And it is actually not just a tool, the serverless, for sort of the young cool kids. What we've seen is an immediate tremendous pickup by serverless of large enterprises and large applications. If you look at ZocDoc, so the business, the very successful business that actually matches patients with doctors, you see that Lambda in their architecture is crucial. There is only business logic in Lambda. There are no servers in this architecture. iRobot, the consumer robot company, they actually have a very strict cost component in mind because their customers only pay for the robot. They don't pay for the cloud services that come with it. And if you look at all the different components that they have in all of these, all the different functionality that they need to do for the robot, they make use of as many managed services as possible, and all their code is serverless, because it means that they never have to pay for idle. So if you pop out one of those, the registration, for example, you can see the typical move. Yeah? API gateway, Lambda, queues, logging, CloudWatch, all managed services in AWS. Agera is a company that actually for most insurance companies delivers this software and tracking mechanisms for how well people drive and whether or not you can actually detect whether they are in accidents. And so 1 in 3 vehicles in the US actually have software from Agera in them. All of this is run on Lambdas. Yeah? Queues, ML prediction engines, all the data and functionality being moved using Lambda, and actually they make use of additional managed services, such as Twilio, to actually do phone calls for you. HomeAway is a very well-established old business, and that actually manages vacation homes for you. And so they basically take in about 6 million photos, I think, a month. Yeah, because all of these individuals that are actually sort of renting out the vacation homes really make use of more and more high-quality imaging. And so as you can see, in their pipeline of image ingestion, there is no server. It is only serverless functionality, both in terms of sort of DynamoDB, S3, the Lambdas that they're using. So basically, data comes in, and these days, very high-quality images get dumped into S3. They actually tone that down to a master image that is about 4,000 by 3,000 pixels. And then they sort of process all of them into thumbnails and to other resolutions for different devices. They manage metadata streams for that. Everything there is a managed service. There is no server involved in this at all. So if I think about sort of some of the things that you keep in mind, hope that you keep in mind when you actually are building serverless applications, that if you use more than one function, you start making use of state machines and step functions to do this, that you no longer start to think about databases, but just think only about tables. Yeah, events as your interfaces, and manage sort of the execution of the different versions of your serverless environment using an encrypted parameter store. And we've delivered quite a bit of technology for you, I think, in the past year. The serverless application model and SAM Local that came with Lambda allows you now not only to have a declarative approach to lay out your serverless application, but also to run that on your laptop, in your plane, while you're actually debugging and working. Lambda at the edge and in Greengrass, the support at the API gateway for proxies and usage plans to separate different usage groups. And I think the recent updates to step functions are very interesting. So where you can actually update the state machine in real time without having to take it down. So we do a lot of good things, I think, in and around this world to continue to be the pioneer in this area, to deliver technologies to you that you cannot get anywhere else. If you really want to continue to be on the forefront of serverless, continue to check out how we're fast innovating in this space. You actually give us a lot of requests continuously. Yeah? More languages, more memory, more functions, deeper integration with our security tools. And I'm happy to announce that at least today, we have knocking off, again, a few of these for you. You get API gateway with VPC integration, meaning that you can run your VPCs, you can run your gateways inside your VPCs. And by the way, if you guys, another announcement that has happened with VPC cross-region VPC sharing, did you check that one out? Actually, yeah, where you have completely encrypted tunnels between your different VPCs in different regions. And not only that we run encrypted tunnels there, we actually anonymize all the packages for you, so whoever would be inspecting these streams cannot even figure out what your IP addresses are and things like that. Yeah. So these small things that we announce around here at re:Invent as well, that have a tremendous impact on how we build our systems. Better concurrency controls, sort of you controlling how many functions can actually run in parallel, 3 megabyte support, and support for, in language for .NET Core 2 language. Okay. And go. You ask, we deliver. Yeah? I'm very happy that we now have Go support. I think many of you have been asking for this one. And why don't you go build and show us what you can do with that? Yeah. So we also want to make sure that you can learn from each other. And not only learn from each other, but learn from sort of people that already have quite a bit of experiences in the world of serverless. And we are launching today something called the AWS Serverless Application Repository, where you and everybody else can put their serverless functions into, and where you can sort of publish and deploy them and allow other people to reuse your functions, and you can learn from them as well. Quite a few of our partners are putting their functions in there, like Splunk and like Twilio, and these functions are immediately for you ready to use to be deployed in your world. So serverless plays an important role, not only in sort of system development, but also in and around areas such as IoT and like machine learning. And many of our enterprise customers have built very extensive architectures with them. So to talk about probably one of the very most exciting customers that we have around the world with a lot of imagery and a lot of very cool applications that they're building with AWS, I'd like to invite Dr. Walter Scott on stage, the Senior Vice President and CTO of Digital Globe. Walter.
Thanks, Werner. Great, appreciate it. Thank you. You know, Digital Globe sits behind many aspects of our mobile digital lives. If you've ever looked up directions or called for an Uber or searched for a trailhead, you've used Digital Globe imagery or information that was derived from it. But it's more than just enabling our mobile digital lives. It's about helping make the world a better place. Whether it is helping find a boat in the middle of the ocean that let reporters and then authorities release over 2,000 slaves who were involved in fishing in the South Pacific, or mapping villages in Africa to find where people were to deliver the right amount of vaccine to the right number of people at the right time, or providing first responders with accurate and up-to-date information before, during, and after a natural disaster, like the devastating fires that went through Santa Rosa, California, just a little over a month ago. Now, there's a lot of information in one of these high-resolution satellite images. Looking overhead, you can see, cars, manhole covers, street markings. But it's a really big planet. And that same amount of information is present over every square inch of that planet. So our satellites collect 80 terabytes of that information every day and downlink it. Think of that as data boulders from space that are big enough to crush just about any IT department on the planet. Well, back in the day before AWS, we built our own data center to store all 100 petabytes of our imagery, but it was stuck in jail. So we decided we were going to go all in on AWS. And let me talk to you about 3 ways in which AWS enabled us to build the Digital Globe, which is a living digital inventory of the surface of the planet. First step was, how do we get our data out of jail? Remember this from last year? It's a snowmobile. Digital Globe was the first customer for snowmobile, big data center on wheels. Here you can see a selfie of our snowmobile at our Colorado headquarters, taken from space. We moved 17 years worth of data to the Amazon cloud in a single, very cost-effective operation, moving it into 2 separate regions in Glacier. Huge step up from our legacy tape plus disk. But in today's digital age, who doesn't expect instantaneous gratification? And the problem was Glacier was very cost effective, but it didn't provide instantaneous access. So that leads me to the second challenge, which is how do we provide on-demand access to our 100 petabyte library while still managing costs and keeping most of the data in Glacier? So let's take a look. Our satellites collect imagery over the entire planet. And so our first step was to say, well, we'll take maybe the last 180 days and do age-based caching. So the blue dots are representing what was stored in the cache. But there were two problems. And by the way, the cache is in S3, which is obviously very performant. Problem number one is big cache. Problem number two, it turns out it still missed a lot. Let's take a look at the customer access patterns. We, over the last few years, have moved from viewing imagery to analyzing imagery. And the net result was that the hit rate went from about 70% down to 40%, which is a horrible cache hit rate. If you take a deeper look at that, this is the pattern that occurred over the course of several days. So it's highly variable. The orange dots are showing you what the accesses are. The purple line is the hit rate. It was diverse, and it also included both current and historical data, because a lot of the accesses were for trending. So we turned to machine learning. Enter SageMaker. Machine learning is a service. So we applied SageMaker to our caching problem. Let's take a closer look. Imagine you're trying to map villages in Africa, the vaccine example that I was using. Now, those villages appear within large image strips that are hundreds of gigabytes, hundreds of square kilometers. So we need to train the caching algorithm to find relevance in customer access patterns. Are people looking for something in the same image or images nearby? Can we predict, based on the usage patterns, where the next access is likely to be and preload that from Glacier before it's even needed? Well, the net result was yes. And we were able to get our cache hit rate up by more than a factor of 2. In fact, it's at 83%, trending to 90%. The cool thing was our infrastructure engineers, really great infrastructure engineers, total noobs in machine learning. And in 1 week, we were able to achieve the result that I just described. And that was all enabled by SageMaker. So now let's move on to the third problem that AWS allowed us to solve, which is extracting information out of that huge image library and doing it at scale. So 100 petabytes of data with 80 terabytes per day. If you had one human looking at 1 day's collection, trying to pull out one kind of feature like the cars or the buildings or the roads, it'd probably take that person about 85 years, and they'd go blind in the process. Not a great answer. So we introduced something called GBDX, Geospatial Big Data Platform. It is geospatial analytics as a service. It's a live service designed to convert that unstructured imagery into structured and analyzable data and pulling out various kinds of features in the imagery. Now, we don't try to do it all ourselves. We, in fact, enable an ecosystem of developers. And so to make it super easy for those developers, we introduced GBDX notebooks built on top of the open source Jupyter Notebooks framework, which are probably familiar to most of you in the data science community and super easy to use. So it provides access to a number of machine learning patterns that might be the same as or close to what you are interested in doing. It provides you the ability to modify, to select the data you want to operate on, to train your model, and then to operate your model at scale by leveraging the tools underneath SageMaker. By the way, I encourage you to try this out, and there's a link at the end of the presentation that will take you to an opportunity to check this out. So combining those components enabled us to solve what were basically 3 hard problems. Number one, satellite imagery is pretty hard to deal with. It's not what most of us are used to. Machine learning is hard, and operating at scale is hard. AWS enabled us to do all 3 of those. And when I say scale, I mean continent scale, like the continent of Australia. It's a big place. 7.5 million square kilometers, 20 million buildings. And if you wanted to map Australia using traditional techniques at the level of detail that is needed in the modern digital world, totally unaffordable. Or you might be able to do it every 5 years. We had the challenge of doing that as a continuously updated service. So we took 200 terabytes of imagery collected over Australia. We worked with our partner, PSMA Australia, to create Geoscape, which is a continuously updated service of the buildings, the roads, the roof materials, the roof heights, the solar panels, the swimming pools, the tree canopies, the heights of the tree canopies. It's the world that we live in, work in, and play in made digital. Now, let me give you 2 examples of how this is being used. The first is for telecom. As telecom moves to 5G, none of us like dropped calls, but unfortunately 5G is blocked by a lot more than the older telecoms were. Like, for example, trees. Who thought to map trees? Who thought that that was actually important to have in a map? Well, for 5G telecom, it turns out that's critical if you want to be able to do tower placement without guesswork. So that's a great example of how GBDX and Geoscape let you save time and resources. How about saving lives? Well, another example is in the outback in Australia, the typical property is huge. And the address is a dot in the middle of the property. It says nothing about where the buildings are or where the people are. Well, in 2015, Australia was suffering from wildfires across a large portion of the continent. And you think about, what does a first responder have to do? They have to figure out how to evacuate people, what are the structures that have to be protected. Well, if they're guessing, that's time. And in a wildfire, time equals risk to life. Geoscape takes the guesswork out of that sort of first response. This has only been possible because of the image library with Digital Globe, GBDX, powered by the scale and ease of use of AWS. And the possibilities are endless. Imagine what you could do. Or actually better, we have a challenge for you. GBDX for sustainability. Digital Globe and AWS want you to join us in an experiment with purpose, come forward with ideas for solutions using machine learning to UN Sustainable Development Goals. Like, for example, good health and well-being. The example I used earlier about vaccines in the developing world, that was actually a machine learning example. We used machine learning combined with crowdsourcing to figure out where the villages were and estimate the number of people who were in them. We encourage you to submit. The winning proposals will get access to GBDX and our 100-petabyte library, and the results will be announced in the late spring. Let's all work together to see a better world. Thank you very much.
Thanks, Walter. Amazing challenge. I urge you all to take part in that. GDBX platform is amazing, and you get access to the whole 100 petabyte of data. So machine learning, as you can see, has impact across the board. Actually, within AWS, you probably see Macy as well as GuardDuty, both security services driven by machine learning, where we sort of GuardDuty looks at sort of learns the normal access patterns to your accounts, and then after that can actually use the models that they've created to actually start looking for anomalies. So we see machine learning being applied everywhere. This is sort of one of these simple building blocks, putting things in a row. You get your Twitter stream, you push it in Kinesis, you use Translate, push it into Comprehend, store it in S3, use Athena, and then push it into QuickSight for quick demonstration about sort of what are the international sort of discussions going on about the particular Twitter topic that you're looking for. This is just really building blocks putting next to each other. You do not have to write almost no business logic there at all. If you go to the Builder Square, the quad, you will see a 737 simulator there. Behind that actually sit a lot of technologies. So that's sort of the hardware interface. The ProSim simulator actually has the unique capabilities of the real flight simulator. But on this side, it is all machine learning. Yeah? Amazon Lex and Polly will talk to the pilot. And the machine learning is actually used to sort of give the pilot advice about the best actions to take. Or basically, it will tell you whether you're crashing the airplane or not. Very crucial advice, I would like to think. So again, all AWS services there. There's a trainer, data flows in there, Lambda puts it in DynamoDB in the fire hose, and then you have the whole set of sort of training models, both MXNet, TensorFlow, as well as some random forest stuff running in EC2 containers. to actually then create networks. And so that, once you've created those, you actually need to deploy them. The simulator actually has a Volta and NVIDIA Volta board on board. So you can actually deploy models to the board locally. And so you have to do all this work for that. Now, let me tell you, if you then use SageMaker, all of that goes away. Yeah? All of the deployment, all the management, all of the complexity that you had before this, to actually manage your models, to train your models, to do the management of them, and then load them onto hardware, wherever that hardware is running, actually, it's all gone. Yeah? Last year, I was fortunate to have Trainline on stage, a very cool company out of the UK who basically sells you train tickets throughout Europe. They actually, now that they are all in on AWS, started doing all sorts of experiments with the data that they have around train tickets. So they made use of machine learning then to start giving customers advice about what would be the right moment to buy your train ticket to actually drive the cost down for them. It seems to be extremely effective. And you see all sorts of reports in the UK press coming back about how well they're serving their customers using these machine learning models. So one area, I think, where there's a deep integration between machine learning and the real world is in machine learning and IoT. So where you have lots of sensors around your environment, that creates new data streams. And then in response to those sensor streams, you can actually sort of execute your machine learning models. And probably there's no better person to actually demonstrate this to us than Matti Kochavi, who is the CEO and co-founder of AGT Heat, that will give us an amazing demo of sensors, machine learning, and real humans. Matti.
Stories. People have been telling stories since our early days. Stories are part of our ancient society and our modern society. The person who was painting on the wall of the cave, or the person who is using the most sophisticated software machine to create an image, both are members of the same tribe, the tribe of storytellers. This tribe of storytellers is on an endless search of telling stories in new ways. Today, we all join this journey.
Ladies and gentlemen, this is the main event of the evening. It's time!
This is Sports Today. We're here with UFC superstars Edson Jr. Barboza and Mark Bonecrusher DeCasey. It's early round 3 of 5 here in Las Vegas. Nice flurry of punches from DeCasey.
This is Sports Tomorrow. Heat Deep Analysis ranks these fighters as two of the most explosive fighters in the UFC.
Ooh, right hook from Barboza.
Barboza's glove sensor measures a force of 7.2 of 10. Heat has DeCasey wavering.
He looks strong, Heat.
DeCasey's left cheek impact detected at 8 of 10, a hard punch. DeCasey's agitation is higher than UFC average for that impact.
DeCasey is smiling. Look at that. He's taunting Barboza, but Barboza's all business.
Don't get confused with his smile. Heat's emotional analysis shows a different perspective. Barboza is confident while DeCasey is passive. Octagon floor sensor measures Barboza's energy up 18%, DeCasey down 10%.
All locked up here, Heat.
DeCasey aggression index is rising fast. Expect a shift soon.
Great sweep by Barboza. DeCasey's back up. He's got his leg, lands a few punches.
The global audience shifts to DeCasey.
Back and forth.
England is with DeCasey while Brazil is pulling hard for their Barboza. While local audience stays with Barboza. Both are strong.
Both are strong. They are bringing it. This is tremendous. What a fight.
Both fighters are gaining confidence.
Wow, double 360 from Barboza. Jacasey blocks. Oh, what a kick by Jacasey. Wow, spectacular. And that's the end of round 3. Now for the inside story with Heed.
Heed has the indices adding up even. While Barboza's punishment index tops at 8.9, Jacasey's aggression index is all the way at 8.7. Historical Fight Analytics says we're in for a 4-round even fight, Gary.
You heard it from Heed. Invite your friends. We're in for an exciting night.
What an amazing fight. Barboza is from Brazil, Jacasey is from England. They just performed a scripted fight, but they are about the real thing. Those guys stand on the octagon in the most toughest, demanding sports in the world, the UFC. What you also saw is how we want to tell sports. What you've seen right now is 2 minutes of a UFC fight where 70 new insights were introduced during that fight. Those insights are covering entire aspects of the fight of Jacasey and Barboza. They cover their passion, they cover the power of the fight, they cover the resiliency, they cover the strategy. All those things happen on the octagon. Shouldn't we tell story of sport that way? Shouldn't sport be told in real time with real data, the real information, the real data, the real insights, and the real emotions? That's what you saw on the big screens, and we're also going to show you how it's going to look today on the smartphone. We are a company which is trying to revolutionize the way we're going to tell sports and live events. So first, who are we? We are a partnership between 2 companies, AGT International, which is my company, which was building such solutions for the industry, and Endeavor, which is a WME IMG company, headed by Ari. Ari, will you please stand up? Headed by Ari Emanuel, who is one of the well-known people in the industry. WME IMG is the largest entertainment and sports and fashion organization in the world. Together, we envisioned this story, how to tell the world with Internet of Things, sports and entertainment. So how do we create 70 insights in 2 minutes, insights that have not been seen before? It all starts with this. It starts with the data that we collect from sensors. If you would see up there what we have right now, we have a camera which has on top of it very smart analytics on the edge. The mat that you see over here is a very smart mat. It can manage movement, analyze pressure, analyze so many things. This mat and the camera are connected to the same center. We also have Thomas, Dr. Thomas Bader. We also have the glove, which is a smart glove. And inside this glove, we have this sensor. This sensor alone can create about 12 different stories. And the stories are from the strength of the punch all the way to the impact the punch had on the other fighter. Very sophisticated stuff. The glove is connected to the mat. It's connected to the camera. We are agnostic to sensors. Our philosophy, a sensor is a storyteller, and it's a great storyteller if it has very good analytics connected to it. So we deal with any sensors. We are covered with thousands of sensors. Over here in this UFC fight, we covered ourselves with audio and video and the things that I just described. Now, all those sensors create data which is flowing up into what we call our world graph. Our world graph is the centerpiece of our product. And actually, it's where everything is happening on top of it. The world graph is the semantic representation of the physical world and the entities participating in it. And the physical world over here was the UFC fight. And the entities were, of course, the 2 fighters, Jacasey and Barboza. Usually the other entities are going to be the cornermen, which Some of us relate to them as coach. Each team has about 3 cornermen. And it's going to be the referee. And of course, it's going to be the physical entities, such as the octagon. And it's going to be the non-abstract entity, which is going to be the fight itself. All those are entities that are on the world graph. The world graph knows everything about those entities, their properties, their dynamics, their complex behavior. The world graph also knows about the relationship between the entities, because we want to tell a story. We are not about statistics of the fight. We are about the story of the fight. So the world graph knows things like the connection between the fighter and between his coach. The world graph is also covering the historical behavior of the fighters. So we know what they've been doing in the past. So what we have on the world graph in real time is the information which comes with the sensors that describe to us the fight, and we have the historical data. On top of the world graph, we have our AI agent. There is a way I want you to think about it. Think about a robot that sits right now in every sport event in the world. Think that robot is connected to sensors that I just told you. And that robot has one mission, is to be able to provide to each one of you what you want to know about the sport event, even if you're not there. So the AI agent that we have that runs on top of the world graph is looking at the world graph and is asking questions. What's interesting, what's important, and what's fun, so I can be able to provide this information in a cool way to my audience and to my fans. And that's what the AI agent is doing, extremely sophisticated agent. And what he also knows is, he knows what each one of us would like to get. It might be that I would like to get the emotional part of the fight, and someone wants to get to know about the physical part of the fight. So he's going to be able also to understand what each one of us want, and to pick from the fight that we saw right now, and from the 70 analytics, to send it to the relevant people, and whatever they want to see. Now, how does this work? And I want to show you this specifically, because this is a very complicated, comprehensive information. Think you're such intense fight on a such small octagon, and to be able to identify all those great emotions and great things. That's the reason why in our company we have more than 100 PhDs who are data scientists, and the same number of developers, and we have artists, and we have visual people, because we believe that the way to tell a story right now is the combination of science and technology and art to be able to tell a great story to all of us, the story of this UFC fight. So you saw the moment in the fight where JKZ was stunting to Barbosa. Of course, it was scripted, but it's based on a real fight. In that moment, something else happened. JKZ got a very strong punch from Barbosa. The AI, who is looking at the world graph, identified that the punch was on the top 10% of that weight class. How does the AI knows that? Because the sensor, which is on the glove, is connected to machine learning and already saw thousands of fights. So the glove tells the AI this was a unique punch. It was on the top 10%. At that moment, the AI begins the trigger of the story. And for him right now, the first thing he's going to do is going to tell all of you who watch the fight, or maybe you're at home and you don't watch the fight, he's going to tell you, hey, by the way, I know you like a UFC fight, right now was a unique punch that Barbosa gave JKZ. But here's another thing that's going to happen. He's going to keep searching and looking for more interesting information. And what he's going to be also finding is going to find the impact of the punch. 8 out of 10 is a strong punch, but what impact it did on JKZ? And the world graph will inform the AI agent, or the robot who's right now sitting and watching for us the fight, will inform him that the impact was 8 out of 10, where 10 is a knockout. Now, each one of us is knockout is a different number. So my 10 is definitely not their 10. So he's going to say it was 8 out of 10, which is a very high number to be 8 out of 10. At this point, the world graph knows that JKZ is under stress. He starts to ignore JKZ's stanting. He doesn't look at that anymore, because he knows he's under stress, but he's checking more information. He finds out that Jacuzzi's energy went down in 10%, all real information. He's also going to look at the coach or the cornerman. The cornerman is participating in the fight. The cornerman has emotions. The cornerman has feelings. So when the cornerman is worried, it means something about his fighter. So we use 3 different analytics over here, for instance, physiological analytics, and video analytics, and audio analytics. By the way, why audio analytics? Because we can see that the verbal activity of the coach to Jacuzzi increases per historical data. So right now, the world graph knows for sure that Jacuzzi is under stress because he got it from him, and he got it from him, or he got it from anyone else. By the way, we also have family members who are over here watching the fight. Family members, can you stand up for a second? Okay, they have also sensors. Thank you. They have sensors. Because why? Because they are part of the fight. They want to say how they feel about the fight. And when they get nervous, they know their family. And also, by the way, we have the same thing you saw. We find out what people feel in Brazil or what people feel in England about the fighters. So right now, all the world is connected to this fight. What happens right now is that the cornerman is also under stress. The AI agent knows right now for clear that Jacuzzi is manipulating the fight. He actually got a very tough punch, and the AI is able to measure something that you should never measure in Las Vegas. He is able to measure the poker face. He is able to measure that Jacuzzi was playing it. And you know what happened to Barbosa? He fell into it because Barbosa, in 85% of the past, every time that he feels that he can get down the opponent, he attacks him. But over here, Barbosa chose to stay away. He believed the taunting. He didn't believe the data that we have. But we, with our AI, we can tell our fans, and we can tell the people who are watching the fight, here is really what's happening. Now, how do we tell it? I'm just talking about it right now for 4 minutes. This is really long. We know no one is watching anymore 4 minutes information. Videos are going down less than a minute. So how do we tell it? We are taking all this data that I just told you for 4 minutes, and we visualize it in the way people look at the world. We visualize it through avatars. The avatars is the best way for us in the UFC. By the way, in other sports, we're using different visualization. The avatars is the best way for us to be able to take a lot of data and to summarize it in real time. Now, I want to tell you something which is very important. The avatar is connected to sensors. So the avatars over here are telling us the real story. They're not just virtual thing. They are the real thing. And sometimes the avatar is going to show us that while Jacuzzi is tenting, he's basically in a tough situation. The avatar will be the real story. And this is the way we're going to tell you the story. If you cannot watch the fight, and you don't have time to watch the fight, and if you don't have time to see the data that we are sending you, you can be connected to Jacuzzi, and you can be connected to Barbosa through their avatars. And you might forget that they have a fight, but you might see right now suddenly on your phone an avatar coming in and tells you Jacuzzi is in trouble, or Barbosa is winning, or Jacuzzi is in great shape, or both of them are winning. And when we talk about winning, you can't win without having great partners. And the great partners that we have for this is Amazon. All this extremely complicated process that I just described to you. And by the way, today as we are talking over here, Dana, I think that we have 2 fights. I think that we have today 2 basketball games in Europe because the entire European Basketball League, which is the NBA of Europe, not as good as the NBA of America, but that's what we got. The NBA of Europe is right now all on our IoT grid, and all the players over there are connected to sensors. And we are testing it right now as we are talking to you, because on January and February next year, all of this is going to be on basketball for the EuroLeague. So all this process that I just described you is on the Amazon, what's one thing I can say about them. We are building over here a very complicated process of how to build storytelling. And Amazon is working with us not as a giant, but also as a startup. They are a startup who works as a giant with us on what we are doing. Ladies and gentlemen, We are focused about telling a new way to tell sports and live events in a new way, to bring into it passion, to show it in real time, to bring the same energy that you have in the game, to have it right now in the information that you get. And all of this is in order to serve you. I hope you're all going to be on our platform and really enjoy it. Thank you very much.
Thank you. Thank you. So originally, I was supposed to fight. However, they couldn't find another fighter in my weight class willing to do this. Yeah. All of this hardcore IoT, analytics, machine learning, all of the important tools that you've seen also yesterday in Andy's keynote. Also was in yesterday's keynote was Deep Lens, the new device that we make available for you so you can play with machine learning. And I'd like to invite my good buddy, Dr. Matt Wood, back on stage, who was with me in the first keynote in 2012 as well, to talk about all things machine learning. Matt.
Thanks. Thank you, Werner, and good morning, everybody. So I'm going to talk a little bit about machine learning, and particularly machine learning moving to the edge. So we've seen a couple of trends over the last couple of years when we talk to customers about their machine learning needs. The first is that a huge amount of machine learning is now happening in the cloud, both with application services such as recognition video, transcribe, comprehend, translate, but also customers building custom models using training, tuning, and inference, which is making predictions against pre-trained models. The second trend that we've seen is around moving that inference, taking trained models and deploying them into connected devices to run them at the edge. And customers do that today in a number of different ways, just by putting the model on the device and burning it into the silicon, or using services such as Lambda at the edge. The approach here is that this is a very useful way of embedding intelligence where a round trip to the cloud has a prohibitive latency, or where these devices may need to operate in disconnected environments. You still want that intelligence to operate on the device, even if it's disconnected from the cloud. But a more common trend is to bridge these two worlds, to be able to take devices that are running inference and integrate them with the cloud. This allows you to put some level of intelligence, effectively a sophisticated enough model that you can get away with, given the hardware that you're operating in, and allow that to integrate back with the cloud. Now, this is actually the exact approach that we take today with Echo and Alexa. So today, the Echo device allows you to operate some speech models, and there we're detecting the wake word. So Alexa, computer, Amazon, you need 3 syllables to be able to do it reliably. But as soon as we hear that wake word, the Echo device starts to stream the audio back to the cloud, where we can run much more sophisticated models. And when we were designing Echo, the idea really came out of a brainstorming effort where we were thinking, what could we build with an infinite amount of compute that we have in the cloud? And we were able to pair that with some sophistication down on the device. And this is the exact same approach that we take with Deep Lens. So with Deep Lens, we're able to run sophisticated vision models down on the device and integrate with more sophisticated models that run on the cloud. So I thought I'd give you a deeper dive into the technology and the innovations which live inside the Deep Lens device. So let's take a closer look. So this is a Deep Lens device. We announced it yesterday. It's the world's first deep learning-enabled wireless video camera for developers. And whilst its specific task is to help developers hone their machine learning skills, under the hood is actually a reference architecture for this hybrid world where we have some sophistication running on the device and integration with more sophisticated models up on the cloud. So let's take a look inside. This is the data flow inside the device. We have a custom chip in there which has 3 main components: an image processing unit, a CPU, and a GPU. And we're able to take the high-definition 1080p H.264 feed off the camera, and we send it into the image processing unit. And that splits the feed into two parts. We call it MPEGification. Now we have an H.264 feed and MPEGs that we can run inference against. And those MPEGs get passed off to the CPU, which is running Greengrass, which allows us to run Lambda functions. And Lambda, with a single line of code, can pass off the inputs and the image onto the model, which is running on the GPU. And it's able to do this in real time. So it takes the images, passes them to the GPU performs inference against them in high performance. We're running at over 100 gigaflops on the device, and then passes the results back to Lambda, and then Lambda can do anything with the results. It's just a normal Lambda function after that. So for example, the GPU can process and identify a face, and then you can pass back that, yes, Lambda, I have seen a face. And only at that point can Lambda say, OK, I've seen a face. Now I'll connect back to the cloud. Because we run on Greengrass, we're able to connect back using secure short-term certificates to the rest of the AWS fleet. So we can then instigate Lambda functions on the back end on AWS. We can send messages through to AWS IoT. We can even initiate text messages or push notifications through Amazon SNS, put images in S3, write items to DynamoDB. The list goes on and on. But in addition to that, the device is capable and can emit a Kinesis video stream. So this is another service that we announced yesterday, which provides real-time video feeds coming onto AWS. So you can send that real-time video feed, both the H.264 feed and the results of any inference or image manipulation you've done down on the device, and send that back to Recognition Video. So Kinesis video streams integrate natively with Recognition Video. And that has much more sophisticated facial analysis, activity detection, content detection, even celebrity detection, which all runs in a fully managed service up on AWS. So just from a single device, because we have this power on the device and the connectivity back to AWS, we're able to build this hybrid mode of running connectivity down on the device. So now let's zoom out one more time. What happens when you want to deploy a new model down onto the device? Well, as we talked about yesterday, you can use SageMaker. You can take all of your data, which stores in S3. You can put them into your model, train and optimize the model. And then as soon as you're ready, you've got a good result. You just click a button, and we send it over the air back to the device. Now, there is a little bit of smarts here. We don't just send the raw model. We actually process and optimize the model in the background for you before we send it down to the device. So we do a couple of things. The first thing is we translate the neural network model that you've trained into the right format to run on the optimized inference engine down on the device. The second thing we do is pruning. We remove all the neural network pieces that you don't need to run inference in a high-performance way. And the third step sounds awesome. It's quantization. With quantization, you're able to take advantage of a neural network's ability to be able to filter out and ignore noise in its signal. This is how image processing works. You're able to look at an image, and despite the noise in the image and anything that might be in the way, or the fact that it's upside down on the right way up, you can still identify an object inside it because the neural network is tolerant to the noise. And we can take advantage of that and improve the performance by reducing the precision of the inference. So we can move from 32-bit precision to 16-bit precision down on the device and still have the inference work and get a good quality result. And that improves the performance. So that allows us to deploy over the air using Greengrass and push down to the device. Now, this is great for learning because you can iterate really, really quickly. You don't have to worry about the quantization and the pruning. It's all there for you. The next thing you can do is a cutting-edge area of research. So it's kind of cool that in a device which is only 249, you can still take advantage of the cutting-edge areas of research. And that's something that people call human-in-the-loop learning. So one of the approaches you can take is where you get a low-confidence result back from your model. Let's say you're trying to detect a cat, and you only get a confidence of 0.4 out of a range of 0 to 1. You can collect up all the images that you're doing poorly at. And you can store those in S3 and write a table to DynamoDB. And then you can pass those images back to real humans so that they can annotate the data more effectively. This is human-in-the-loop learning, and it allows you to iteratively improve the data sets which you're using to produce your model using human intelligence. So we have a service for this that we call Mechanical Turk, which you can take advantage of today. Or you can use internal experts to your domain. Once you've got their human annotations, you can pass those back up into AWS, you can improve the results and improve the quality of your data. Then because SageMaker is so easy to use, you can just throw those back into your model, click the button, and deploy it back to your device. So this is a very capable way of running machine learning at the edge, which we think is an awesome way to get fast iteration and immediate gratification, as well as exploring some of the more advanced concepts of running machine learning in the cloud and at the edge, and integrating it with real humans. So the faster you can spin this loop, the better it is for your learning, both for yourself as you hone your skills, and also the learning of your models. Now, we were very lucky on this project to work very closely with our friends over at Intel. And so to talk a little bit more about our partnership, I'd like to welcome up on stage Naveen Rao, who's the CVP for Artificial Intelligence at Intel. Naveen.
Hi, Matt.
Hey, Naveen.
Good to see you.
Good to see you. Thanks for coming.
So everyone knows we're not going to be fighting.
Yeah, they've taken the mat away. No one wants to see that. So when we started thinking about the DeepLens project, we quickly arrived at the idea that we wanted to use the Intel Atom processor. So why don't you tell us all about what that is and why it's so awesome?
Well, first off, it's a rock-solid platform to start from. So Atom is used in a variety of different endpoint applications. And basically, we can leverage the investments that have been made across many different types of applications for this project. It's also a great computer vision platform. As Matt mentioned, it has a video codec on it, so we can actually encode video natively in hardware. It also has a GPU and has standard Intel architecture support. So this makes it very easy to move from these cloud-based applications via the Lambda functions onto this device. In addition to that, we provided a lot of the optimized libraries with a compile time library called CLDNN that allowed us to stay within the power budget that was allotted by you guys to actually build the device that we need.
Yeah, it's been a great partnership. So as we kind of start to scan forwards, can you tell us a little bit about your vision for machine learning at the edge?
Yeah, so AI is still really in its infancy in a lot of ways, and I think we're seeing some applications that come out there. So this kind of devices are very exciting for us because it really does start linking the data center with the edge, and so we're seeing really an insatiable demand for data center AI, and now moving it out to the edge where we can actually interact with the world. So IoT devices are great because they can actually allow us to monitor what's happening in the real world and then drive that back. And so I think that's really what drives demand here. And having things like Greengrass are really the way to make that happen for developers, right? They don't have to think about all the details of moving these models out there. So it's a great platform.
Awesome. So I'm going to put you on the spot now. You didn't bring a crystal ball, but any predictions for artificial intelligence over the next 18 months?
Well, so my training is actually as a neuroscientist, and so I tend to look at biology sometimes. And what we do see in biology is an aggregation of data at different points. So I think right now we're seeing, like you mentioned with Alexa, you have the edge device and then you have the cloud. I think we'll start seeing some aggregation locally and some local learning. So some of the products we'll be coming out with are actually built around that kind of concept. And yeah, I'm looking forward to this partnership continuing.
Awesome. Can't wait to see them. So thank you very much. I can't wait to see what you build with DeepLens. And with that, we'll hand it back to Werner. Thanks a lot.
Thank you.
Thanks, guys. Thank you. So as you probably have figured out, I can't keep time. Yeah. So thank you all that still are here for sticking around. We've got a few more things, a few small things to go. Yeah, but quite a few of the sessions have been pushed back. Definitely when it's here around the area, so don't panic too much. This is a famous quote from Dijkstra, who is one of the founders, I would say, of modern computing as well as distributed computing. And one of the things about Dijkstra was he was an extremely principled computer scientist. And in all the writing that he did, you should actually read it. It's amazing. Basically, 40, 50 years ago, he already predicted much of how we do development today. So this is one of his famous quotes, yeah, that if you would be 10 years from now, you would be programming, and you would be doing something quick and dirty, which he was always opposed to. And you would feel Dijkstra looking over your shoulder. You would think, oh no, we're not going to do that. So actually, I've modified this quote. Yeah? That is, I won't say 10 years from now, but just do 5 years from now. Yeah? If you're doing something and you're not using an AWS service while it is available for you, yeah? And you will feel and think like, oh, Werner wouldn't have liked this. Yeah? That would be good enough for me. Yeah? So with that, you've got one more announcement to go, of course. Eh? So we've got a party tonight. And so I think we've had amazing DJs in the past years with deadmau5, Skrillex, Zad, Martin Garrix last year, the #1 DJ, according to DJ Magazine in the world. So I thought it was time to actually go a bit more international even and get ourselves a French DJ tonight. And we're very fortunate that we could get the DJ that was closing out Ultra Music Fest in Miami this year, DJ Snake. So with that, we're getting to an end. Thank you all for sticking it out here. A few things to recap. Voice will be the next major disruption in how you're going to build your systems. Yeah? If you're now building systems, think about a voice interface. Yeah? You're all security engineers now. Security should be your priority #1. When you start thinking about reliability, think about your business reasons as well. Why do you want that reliability and what the trade-offs are in cost? And as last, I think the future really is the way that we've been building our services for you, and that the true premise of cloud is just around the corner. Soon you will only be writing business logic. So with that, with all these tools that we've given you, yeah, please go build.
Go, build,
Thank you guys.
build, go, build, go build, go build, go build, go build.